Well, good afternoon. Welcome to the boardroom of the National Transportation Safety Board. I am Robert Sumwalt, and I'm honored to serve as the chairman of the NTSB. And joining us today are my colleagues, Vice Chairman Bruce Landsberg, Member Earl Weiner, and Member Jennifer Homendy. Today we meet in open session as required by the government and the Sunshine Act to consider the derailment of Amtrak passenger train 501 from a highway overpass near DuPont, Washington on the morning of December the 18th, 2017. At about 7:34 a.m., after approaching a 30-mile-an-hour curve at 78 miles per hour, the train, consisting of 10 passenger rail cars, a power rail car, a baggage rail car, and a locomotive at each end, derailed. Some of the rail cars entered Highway I-5 below, hitting several motor vehicles. Tragically, of the 83 people on the train, 3 passengers died, and 57 passengers and crew members were injured. In addition, 8 people in highway vehicles were injured. On behalf of all of us at the NTSB, we offer our sincerest condolences to the family and friends of those who lost their lives. And for those who were injured, we wish the fullest possible recovery. As you know, the goal of NTSB safety investigations is to learn safety lessons of accidents in order to improve safety and prevent future accidents. Could this accident have been prevented? The answer is a resounding yes. 3 people did not have to die. 57 others on board the train and 8 on highway vehicles did not have to suffer injuries. None of us had to be here today. At the simplest level, positive train control, or PTC, prevents overspeed derailments, period. The sooner PTC is operational nationwide, the sooner that railroads will operate at greatly reduced risk of an overspeed derailment. Beginning revenue service on the Point Defiance bypass before PTC was operational, it set up the engineer to fail. Today, we once again ask how an engineer could operate a train at high speed, this time 78 miles per hour, into an area with a much lower speed, in this case, 30-mile-an-hour speed limit. How often have we asked that question, plugging in different numbers and different engineers? They all fail to respond to significant speed changes. And the reasons for this vary, but there is one common denominator: necessary decreases in speed limits going into sharp curves with insufficient mitigation. For example, in 2013, when a Metro North train derailed in the Bronx, New York, killing 4 and injuring at least 61, the train was operating from an 80-mile-an-hour straight section of track into a 30-mile-an-hour curve. And when, in 2015, Amtrak 188 near Philadelphia, it derailed, claiming 8 lives and injuring 185, that was a train that was operating from a 110-mile-an-hour straight section into a 50-mile-an-hour curve. There's certainly a recent history of this type of accident, and it extends back decades as well. From these previous accidents, and numerous strategies were mandated. Mitigations that should have been put in place to prevent the DuPont tragedy. For DuPont, the question becomes, how could a 70-mile-an-hour speed limit be followed by a 30-mile-an-hour curve speed limit at the entrance to an accident curve without appropriate mitigations? The Federal Railroad Administration, or FRA, and Congress have both acted to identify and mitigate the hazards of substantial drops in speed. Yet, as we will discuss, neither contemplated an ongoing survey to identify such substantial drops in speed. Since the accident curve was new, it was missed by one-time surveys. We will also discuss the engineer's familiarity with the equipment and the territory he was expected to know. The engineer had little experience on the territory and even less experience on the territory at the controls of the type of locomotive he was operating that morning. Today, we will discuss whether and how such a training gap was permitted to arise and what measures would be needed to close this training gap. In this derailment, the engineer did understand that he would have to slow down for a 30-mile-an-hour curve, but he lost track of where he was on the accident territory. Quite simply, he lost positional awareness. Did the signage along the route help him? We know that on a new route, especially, signage takes on increased importance because the engineer isn't familiar with local landmarks that can aid in determining position. Yet the engineer missed the single sign that warned of the upcoming 30-mile-an-hour curve, 2 miles in advance of that speed change. Today, we will discuss whether additional conspicuous signage might have helped to mitigate the risk of overspeed derailment. Sound Transit was responsible for preparing the track and its associated signals and signage for revenue service, and they performed a preliminary hazard analysis in 2015. The accident curve was identified, and there were 3 mitigation strategies in addition to the existing timetable. 2 strategies consisted of complying with FRA regulations. The third, future PTC, was not operational when revenue service began. Yet Sound Transit did not identify additional mitigation measures before certifying the property for revenue service. On July the 10th and the 11th of last year, the NTSB conducted an investigative hearing on this accident. This hearing gave investigators and board members the opportunity to understand where the responsibility lay for hazard mitigation. In the hearing, we also discussed the Talgo Series 6 train set, which was only permitted in service through a grandfathering agreement from the FRA. We will discuss whether the items covered by the grandfathering agreement were performed adequately. And we'll discuss ways to further enhance occupant protection, even in less vulnerable rolling stock. Switching topics. After the same accident that resulted in the law mandating PTC installation, the NTSB recommended that FRA require inward and outward-facing audio and video recorders in locomotive cabs. Due to the presence of this equipment, a rich record of the accident trip was available to investigators. It went a long way toward pinpointing the actions that were taken and not taken in the cab of the locomotive on the day of the accident. Kudos to Amtrak for installing this equipment, even though it has not yet been required. But no camera can capture the layered interactions of a host and tenant railroads with each other, with the FRA, and with other entities such as state departments of transportation. These relationships continue to play a part in railroad accidents. Amtrak continues its progress toward safety management systems in an ongoing pursuit of safety above and beyond required standards. However, in our investigative hearing, we recognize that Amtrak's safety is largely dependent on host railroad safety. And one question is how to implement SMS on Amtrak's host railroads. Part of the answer would be for the FRA to issue its long-delayed regulation, known as Part 270, which is a system safety program. We'll discuss others. Staff have pursued all avenues in proposing findings of probable cause and recommendations to the board. The order of the meeting will be that staff will basically give 5 presentations. They will present the facts and the analysis found in the draft report, and then we on the board, we will take turns questioning the staff. We will offer, propose, and vote on any amendments that may be offered during the board meeting. Our ultimate goal is to ensure that the report as we adopt it today truly provides the best opportunity to enhance safety. The public docket for the accident and for the investigative hearing, literally containing over thousands of pages of material, are both available at ntsb.gov. They contain additional information, including photographs, post-accident interviews, and exhibits from our hearing. Once finalized, the accident report will be posted on our website, and that will take a few weeks for all of the editorial and amendments to be incorporated. Now, Deputy Managing Director Paul Sledzik, if you'll please introduce the staff. Good afternoon.
Thank you, Chairman. A few announcements before we begin. I kindly request that those here in the boardroom, please, if you've not already done so, silence your mobile phones and other electronic devices. There are two exits in the front of the auditorium to either side of the dais, one to the left and one to the right. Go down these stairs, out the door, and follow the illuminated signs to depart the boardroom. You may also exit out the rear of the boardroom, the same door that you came in. Proceed out the glass doors, go up the stairs, again through the glass doors, and turn left and follow the sidewalk out to the street. In the event of an emergency, please walk quickly to the nearest exit and make your way outside and follow any instructions that NTSB staff may give you. Do not return to the boardroom until we notify you. Also, there is an AED device located in the lobby of this building. If you have any questions or concerns, please don't hesitate to contact any of the NTSB staff here in the boardroom. Seated at the panel here this morning, unless otherwise noted, are staff from the Office of Rail, Pipeline, and Hazardous Materials Investigations. On the first row, to my right, is Dave Bucher, Chief of the Rail Division. To his right is Mike Hiller, the investigator in charge for this accident, and who will also discuss crashworthiness issues. To his right is Dr. Steve Jenner, who will discuss operations and human performance. To his right is Ryan Frigo, who will discuss system safety. To his right is Cheryl Harley from the Office of Highway Safety, who will address survival factors areas. Behind her, on the next row, is Tim DePape, who examined signal and train control systems in this investigation. To his left is Charles Cates from the Office of Research and Engineering in the Vehicle Recorders Division. To his left is Dr. Matt Fox, also from the Office of Research and Engineering in the Materials Laboratory Division. To his left is Barbara Check, Deputy Director of the Office of Research and Engineering. And to her left is Kathy Silbaugh, the agency's General Counsel. And finally, in that row, to her left is Darlene Hatchett, Director of the Office of Safety Recommendations and Communications. Behind Ms. Hatchett in the last row is Dana Sanzo, Deputy Chief of the Rail Division, who will be handing visuals this afternoon. To her right is Eldridge Harding, Editor in the Office of Rail, Pipeline, and Hazardous Materials Investigations. To his right is Dr. Mary Pat McKay, the agency's Chief Medical Officer. To her right is Jeff Marcus, Acting Chief of the Safety Recommendations Division in the Office of Safety Recommendations and Communications. To his right is Dr. Bob Beaton, Chief of the System Safety Division in the Office of Rail, Pipeline, and Hazardous Materials Investigations. And lastly, to his right is Joey Ryan, who will cover mechanical issues dealing with this accident. This afternoon's presentations will begin with an accident overview by the investigator in charge, Mike Hiller.
Good afternoon, Chairman Sumalt, Vice Chairman Landsberg, Member Weiner, and Member Hamady. On December 18th, 2017, at 7:34 a.m., a southbound Amtrak passenger train, 501, consisting of 10 passenger rail cars, a power and a baggage rail car, and a locomotive at either end, derailed from a bridge near DuPont, Washington. When the train derailed, it was on its first revenue service run on single main track of the Lakewood subdivision. This map shows an inset that zooms in on the Point Defiance bypass. The original route went north out of Tacoma, staying along the coastline of the Puget Sound and ending just south of DuPont. The new route is nearly a direct line from Tacoma to south of DuPont. There's a call out showing the accident location near DuPont just prior to the Point Defiance bypass joining the original route. Several passenger rail cars fell onto Interstate 5 and hit multiple highway vehicles. At the time of the accident, 77 passengers, 5 Amtrak employees, and a Talgo technician were on the train. Of these individuals, 3 passengers were killed and 57 passengers and crew were transported to nearby hospitals. Additionally, 8 individuals in highway vehicles were injured. The damage is estimated to be more than $25.8 million. This photograph was taken during the day after the derailment. The Point Defiance Bypass project was funded by the Washington State Department of Transportation and federal grants administered by the Federal Railroad Administration. WashDOT contracted with Sound Transit to complete the bypass. Sound Transit hired and managed contractors who undertook the work. All improvements are owned by Sound Transit, who is also responsible for track operation and maintenance on the bypass. Sound Transit contracted BNS for dispatching the trains on the bypass. WashDOT contracted Amtrak to provide operations that includes training operating crews on the newly upgraded Point Defiance bypass. Talgo maintains the passenger trains through a maintenance contract with WashDOT. Amtrak is the railroad of record responsible for developing operating rules, practices, and procedures. The investigation team. NTSB staff supporting this investigation. Parties to this investigation. The safety issues identified in this investigation are the individual and multi-agency responsibilities in preparation for inaugural service on the Point Defiance bypass, Amtrak safety on a host railroad, training and qualifying operating crews, crashworthiness of the Talgo equipment, survival factors, and multi-agency emergency response. This concludes my opening presentation. Dr. Jenner will now discuss operations and human performance.
Good afternoon. The Operations and Human Performance Investigation examined the reasons why the Amtrak operating crew failed to slow their train at the curve and assessed how they were trained and prepared for operating on the Point Defiance bypass. This was the very first trip made by an Amtrak crew in revenue service and the first trip the engineer made operating the Charger locomotive without supervision. The engineer had been a certified engineer for about 4 years and had a good performance record. He felt that he was ready to operate on the new territory, and so did the Amtrak managers in charge of the qualification process. The engineer was accompanied in the locomotive by a certified conductor with about 5 years' experience. We refer to him as the qualifying conductor because he had never traveled over the Point Defiance bypass and was in the process of qualifying on that territory. The investigation eliminated many of the human factors that could have affected the engineer's performance, including his health, fatigue, drugs, and alcohol. The inward-facing video showed there was no distraction from cell phone use or radio communications with the train dispatchers. Both crew members were looking forward and occasionally at their paperwork. Both appeared to be attentive. There was only occasional conversation between the crew members, but that did not appear to distract the engineer from his duties. I'd like to go through the accident trip in a little more detail to highlight some of the safety issues uncovered in this investigation. This is a diagram of the last 2 miles of the accident trip. The train was operating southbound from the upper right of the picture to the bottom left where the derailment occurred at milepost 19.8. The crew departed at 6:10 a.m. in the dark. The trip was uneventful until the last 2 miles. As the train traveled south, the engineer saw the signs for milepost 16 and milepost 17. At milepost 17.8, there was an advance warning sign. The sign is an indication that the curve at milepost 19.8 was 2 miles ahead of them. The engineer did not recall seeing this sign. He also did not recall seeing the sign at milepost 18. The next relevant sign was associated with the signal at milepost 18.8. This sign was particularly important to him because it was 1 mile before the curve and the location where he had intended to begin braking to slow down for the curve. However, he missed this sign as well. Finally, he took no action to slow the train at milepost 19. Moments later, a little more than half a mile and about 27 seconds from the curve, with the train traveling at 82 miles per hour, an alarm was heard in the cab and lights on 2 screens on the control panel began flashing. This was an overspeed alarm that was set to alert the crew when the train was traveling about 3 miles per hour beyond the authorized speed for that train. The red line represents the approximate location and duration that the engineer was focused on this alarm. The engineer had never experienced this alarm while operating the new Charger locomotive and did not immediately recognize what was being presented on the two screens. In fact, inward-facing video shows that he was scanning both screens for about 20 seconds, trying to assess the situation. During this period, however, he rarely looked outside the train, which had now traveled another half mile and was nearing the curve. The engineer finally did understand the alarm, but only seconds later he recognized where he was, and it was too late to avoid the derailment. The errors that occurred on the accident trip shed light on several safety issues, which I'd like to highlight. First, even though the engineer was engaged in train operations and was looking ahead, he was unable to identify key milepost signs critical to safe train operations. These signs help crews identify their location so they have adequate time to stop or slow the train for stations, slow orders, and curves. This failure to detect these signs suggests that he was not adequately prepared on the physical characteristics of the new territory. That is, he was not proficient in locating critical signs or landmarks to clue him in about his location. During their training, engineers were given a number of observational rides over the territory, but they were only required to have as few as 2 trips behind the throttle operating the train. The accident engineer had made 3 training trips, but only 1 was southbound, like on the day of the accident. Consequently, staff has proposed a safety recommendation that crews demonstrate their proficiency of a new territory through improved training, greater experience operating the train, and testing under all conditions. Second, the engineer's training on the new Charger locomotive included classroom instruction months earlier, walking on a parked locomotive, and riding during qualification runs. However, this process did not expose him to all its features, such as some critical alarms. This is a photograph of the control panel on the locomotive cab, with the left and right screens highlighted in yellow. On the PowerPoint slide, the right picture shows overspeed that we circled in red. The text overspeed will flash in the case of an overspeed situation. In addition, the no traction train indicator will be displayed in the red box just off center. That is also related to the overspeed event. However, this was the first time the engineer had seen that indicator. The main takeaway is this. When the overspeed alarm was activated, the engineer was presented with information on the screen he had not seen before in this or other locomotives, and he appeared confused. He needed time to evaluate the information, but that reduced his vigilance outside the train. So staff is proposing a safety recommendation for Amtrak to revise its training, including the use of simulators when operating new locomotives, to ensure that crews are experienced with all features of the locomotive before operating it on the road. Furthermore, staff contends that the overall plans for training crews to operate on the territory would benefit by being more formalized rather than having plans developed based on personal experiences. A more formal or systematic approach, such as using a task analysis, would help identify and strategically address the combined challenges of simultaneously operating new equipment on new territories by crews who had little experience doing either of those tasks. So staff has proposed a recommendations for a more formalized and systematic process for determining the appropriate level of training to fully prepare crews for all types of challenges. A third area where staff believes that safety can be improved is through maximizing crew resources in the operating cab. As I discussed, the engineer was accompanied by a conductor making his first qualifying trip on the territory. Beyond calling out signals with the engineer, the qualifying conductor saw his role as passive and to learn as much as he could. He did nothing wrong during the trip. But staff suggests that an experienced conductor, even if he's unqualified on a territory, can play a critical and active role in helping to establish and maintain safe operations and take action when things may not be going well. For instance, the territory and the equipment were new to them. That should motivate crews to work closely together to ensure they identify key signs and signals and to make sure that new or ambiguous information is strategically addressed. By applying crew resource management principles, which is part of Amtrak's training, a conductor may have recognized that the engineer's confusion with the alarms was a clue that he was struggling and unable to maintain vigilance outside the train. That may have prompted the conductor to intervene and perhaps even stop the train himself if he thought it was necessary. Therefore, staff is proposing a recommendation that Amtrak provide training that reinforces how even the most inexperienced or junior crew members can be an important resource for maintaining safe train operations. And finally, staff believes that enhanced wayside signage could help crews identify their location. I mentioned earlier that exactly 2 miles before the curve, the crew passed an advance warning sign, which is enlarged in this photo for clarity. The signs are positioned at an angle with T30 and P30 indicating that in 2 miles, the speed limit for T Talgo and P passenger trains is 30 miles per hour. The Amtrak engineer did not recall seeing this particular sign and told investigators that he didn't pay much attention to it because it wasn't particularly relevant to him. Advance warning signs at this location can be particularly important for freight trains because 2 miles before the curve is where many freight train engineers begin to slow their trains. So it's an operationally relevant cue to them. But that's not the case for crews of passenger trains. Passenger train crews will slow their trains down about 1 mile before the curve. However, there are no similar warning signs around the 1 mile mark to cue the passenger train crews. Staff referenced highway guidelines for signage and noted that on highways, supplemental signs or plaques, which can be used in conjunction with advance warning signs, can be installed to further remind operators of an upcoming hazard. So staff is proposing a recommendation that Amtrak and host railroads explore the use of supplementary signs placed at strategic locations that would benefit operating crews of all trains operating over the territory. This concludes my presentation. Mr. Frigo will now discuss system safety.
Excuse me just for a moment, and I want to clarify for the people who are watching. The overspeed that you indicated had nothing to do with the fact that he was approaching the speed at the curve at too high of a speed. It was because he exceeded 79 miles an hour by a few miles an hour.
That is correct.
I just wanted to clarify that for people watching. You may have said that, but thank you.
Good afternoon. As you have just heard, Dr. Jenner presented the operational and human performance safety issues associated with the train engineers overspeeding at the time of the accident. Undoubtedly, the lack of training for the engineer played a significant role in this accident. However, during the project design, construction, and safety certification phase, there were numerous missed opportunities to prevent these errors from becoming a reality during revenue operations. As introduced in the opening presentation, there were many agencies involved in the opening of the Point Defiance bypass. Washington State Department of Transportation, WashDOT, received a grant from the Federal Railroad Administration, FRA, to upgrade the Lakewood subdivision. WashDOT contracted the planning and construction to the owner of the subdivision, Sound Transit. Amtrak operates trains through a contract with WashDOT. The FRA was responsible for administering the grant and providing oversight of the project. As I discuss later in this presentation, this oversight is limited during pre-revenue phases. Neither Sound Transit's or Amtrak's operating documents were up to date on the day of the accident. In 2015, 2 years before the accident, Sound Transit issued timetable number 1 for the Lakewood subdivision. This timetable included a crew focus zone, which required additional vigilance and communication between the train crew in advance of a permanent speed restriction. A crew focus zone at milepost 3.4 specifically required communication between the engineer and conductor no less than 1 mile before the speed restriction. The conductor is required to stop the train if the engineer fails to acknowledge this communication. In 2017, in preparation for the completion of the bypass, Sound Transit issued timetable number 2. In this timetable, the speed restriction at northbound milepost 3.4 continued to be acknowledged as a crew focus zone. However, milepost 19.8, the accident curve, with a permanent speed restriction of 30 miles per hour, was not included. By excluding this, Sound Transit failed to apply the same level of risk mitigation to passenger trains throughout the subdivision. In 2016, Amtrak developed a speed limit action plan that listed all locations throughout the Amtrak national network where permanent speed restrictions were in place. Along with other mitigations, this plan also included the use of crew focus zones. On the day of the accident, the Lakewood subdivision was not included in this plan. After the accident, Amtrak officials told investigators that their operating plan was to include a crew focus zone at milepost 19.8 in January, 1 month after starting service. Sound Transit conducts safety certification and verification activities of new and refurbished infrastructure in accordance with the Sound Transit Safety and Security Management Plan, SSMP. Sound Transit's hazard management process includes methods for identifying, evaluating, mitigate, and resolving safety risks throughout all phases of a project, including preliminary engineering, final design, testing, and the startup of revenue service. During the earliest phases of the project, Sound Transit developed a preliminary hazard analysis, PHA, which documented and defined hazards present on the new system. In 2015, Sound Transit identified the hazard of an overspeed derailment in all curves along the Point Defiance bypass. This hazard was determined to be unacceptable, and Sound Transit developed the following mitigations. Ensure curves and speed limitations are designed according to federal regulations, develop inspection and maintenance procedures to meet federal regulations, and the future implementation of positive train control, or PTC. To validate the safety management process, Sound Transit completed a series of integrated tests. The test plan included a section on pre-revenue operations. However, tests in this area were not completed. A typical pre-revenue operations test will include simulated operations at track speeds under various operating conditions. Sound Transit's SSMP specifies that an operating hazard analysis will be initiated during the construction phase of a project and continue through pre-revenue testing. Neither an operating hazard analysis or a pre-revenue operations test were performed on the bypass during the transition from construction to revenue service. With this omission, Sound Transit was unable to verify if the mitigations to control the risk of an overspeed derailment in curves would actually work under operating conditions. The Sound Transit Safety Certification Plan required that all elements of the project complied with safety requirements. These requirements included mitigations developed through the hazard management process. For the bypass, a certifiable items list was used as a final verification tool to ensure that all elements had been tested and verified. This process included a description of the final mitigations to the hazard of a derailment in a curve. These mitigations were the same as originally developed in the PHA, and a procedural control, the timetable, was added. However, procedural controls are the lowest level of risk resolution. Prior to initiating revenue service, the Chief Safety and Quality Assurance Officer certified compliance through a safety certification verification report. The report did not contain an operating hazard analysis or pre-revenue operations testing. indicating a less than thorough safety review. Additionally, the hazard associated with derailments and curves was overlooked during the process, and the mitigation was erroneously classified as completed, accepted. If Sound Transit exercised due diligence during safety certification, they would have recognized through their own process that the hazard mitigations to address an overspeed derailment did not exist. Ideally, Sound Transit could have waited until PTC was completely installed and operational before allowing passenger service on the Point Defiance bypass. In its contract with Sound Transit for the construction and completion of the project, WashDOT required Sound Transit to certify that the project was safe and ready for use in revenue operations. Although WashDOT staff ensured that the project was proceeding according to schedule and budget, their role in overseeing safety was limited. One WashDOT staff member participated in both Sound Transit's PHA activities and some testing. However, WashDOT did not have a formalized approach to oversee the implementation of Sound Transit's safety certification process, nor was there a requirement to do so. The FRA's role in project oversight is split between grant oversight and safety oversight. Safety policies and procedures in the project grantee's SSMP are required, but the FRA has no regulatory authority to approve or require changes to an SSMP. The FRA Passenger Rail Division will perform site visits and observe pre-revenue activities. On the bypass, the division reviewed Sound Transit's hazard management program, but only as a deliverable of the grant. There were also 34 field and compliance inspections conducted by the FRA Regional Office. This was a missed opportunity, as none of these inspections notated the deficiencies that were evident during the safety certification phase of the project. Since the FRA's role in SSMP oversight is limited, they were unable to ensure that hazard mitigations in lieu of PTC were implemented. The majority of routes used by Amtrak to provide national service is over a host railroad. Amtrak uses a host railroad agreement to gain access to the host right-of-way. However, safety issues are not part of this agreement. In this accident, the safety roles and responsibilities during pre-revenue activities were vague. As the eventual operator of passenger rail service over the bypass, Amtrak should have taken a more proactive role in verifying that safety certification activities were complete. Following this accident, Amtrak officials developed a risk assessment process to evaluate the risks to Amtrak operations over a new or upgraded service. Since its development, this risk assessment process has been used several times by Amtrak, including the proposed return to service on the bypass. When operating on a host railroad, Amtrak relies on that host railroad to meet the minimum federal safety standards to ensure safe operations of Amtrak trains. However, on its own territory, Amtrak aims to meet and exceed these standards by historically using a system safety program plan, and more recently, after a recommendation from the board, implementing a safety management system. An SMS should enhance the management of safety, but it may be challenging for Amtrak to implement across all of its network. Amtrak's planned improvements should go beyond the minimum current standards used by host railroads. On April 3rd, 2016, Amtrak Train 89 struck a backhoe and killed 2 employees on the Northeast Corridor near Chester, Pennsylvania. As a result of this accident, the board recommended Amtrak implement a system safety program. One of the challenges faced by Amtrak and all passenger railroads in developing a formal system safety program has been the failure of the FRA to implement its final system safety rule. In the 2.5 years since the final rule was published, the FRA has granted 6 extensions that have deferred this rule until at least September 4th, 2019. The continued postponement has delayed needed safety improvements for the passenger rail industry. Therefore, staff is proposing to reiterate safety recommendation R1717 and to issue a new recommendation to the Secretary of the Department of Transportation. In summary, staff is proposing recommendations for the following safety issues: the inconsistency of speed limit reduction risk mitigations, the coordination of pre-revenue activities, including safety certification and verification, the initiation of passenger train operations prior to the completion of PTC, the failure to update critical operating documents prior to initiating passenger service, the acceptance of risk when operating passenger trains over a host railroad, and the continued delay to critical passenger rail safety regulatory requirements. This concludes my presentation. Mr. Hiller will now discuss equipment crashworthiness.
Good afternoon. In this presentation, I will provide an overview of the derailment kinematics and discuss the more severely damaged rail cars and released rolling assemblies. Next, I will discuss the Talgo Series 6 train set and its crashworthiness design. I'll then provide background on U.S. passenger equipment safety requirements and a grandfathering provision that was necessary for these passenger cars. I'll then discuss the performance of the train set in this accident, and lastly, I will discuss the safety issues identified in this investigation. When the train set derailed, it was subjected to severe longitudinal loads and bending moments as a result of the sudden deceleration from its interaction with the surrounding environment. The forces associated with the derailment caused the leading locomotive to separate from the first rail car in the train set, and several of the connections of the cars in the train set to break. Several passenger cars separated, which triggered the release of rolling assemblies. The locomotive and derailed rail cars were then exposed to secondary collisions after they derailed from the tracks. A total of 6 train set connections failed and 5 rolling assemblies fully released into the surrounding area, shown in red on this graphic. When the 8th car in the train set separated, it struck a nearby concrete bridge abutment, then traveled off the overpass. The rail car then nosed downward, upended, and overturned end over end, resting on its roof, and then struck a truck and trailer traveling on Interstate 5. 4 of 5 right side passenger windows were missing. The end wall of this car was completely separated from the end frame as a result of its collision with the truck and trailer and other secondary collisions as it fell from the embankment. 4 of 5 left side windows were missing. In total, there were 11 passengers traveling in this rail car. 5 were ejected and 10 were injured, and 4 of those injuries were deemed severe. The secondary collisions and interactions with the surrounding environment resulted in about 30% of the right sidewall shearing from the side sill and roof line. After it separated, the 7th car came to rest on its left side against the 4th and 5th rail car. During the derailment and secondary collisions, it rotated 180 degrees from its original direction of travel. The left side of the car was structurally compromised after colliding with the rolling assembly from the 10th rail car. Investigators determined that the collision occurred prior to the bridge near a concrete foundation. At its point of rest, lying partially within the car, was a complete, severely deformed 4,500-pound rolling assembly. The towers of the rolling assembly are typically parallel. You can see in this photo they are twisted. The wheels of the rolling assembly lay immediately outside of the deformed left side of the car. Post-accident observations showed that 2 of the 3 killed passengers in this car came in contact with this rolling assembly. The design of the Talgo Series 6 train set rolling assembly made it susceptible to detachment when the car-to-car connections failed. As you saw on the previous slide, 1 detached rolling assembly was involved in a collision, resulting in 3 fatalities. The rolling assembly of the 8th car detached and extensively became a missile as it traveled across the southbound lanes of Interstate 5. A green Kia and black Jeep were struck by the rolling assembly. Both vehicles sustained extensive crush damage resulting from the impact. Both drivers and 1 passenger were injured. The passenger train involved in this derailment was designed and manufactured by Talgo Incorporated. Talgo Series 6 trains started service in the state of Washington in 1998 and are operated by Amtrak. This train set was constructed prior to the 1999 final rule for passenger equipment safety standards. This rule became Title 49, Code of Federal Regulations, Part 238. The trains are constructed of lightweight, high-strength aluminum. Each car of the train set is semi-permanently joined to the adjacent car through an articulated connection. The train set is designed with one rolling assembly located between each passenger car, except for the baggage car, which has two rolling assemblies. The rolling assemblies consist of wheels and axles mounted in a frame and two vertical columns known as towers. Pneumatic diaphragms are attached to the top of the towers, and the diaphragms are mounted to the top of the car in a framed assembly. This is referred to as the supported end of the car. Two weight-bearing bars, shown in red, are attached to the supported ends of the car at the top and are joined to the opposite end of the adjacent car. The adjacent car is referred to as the suspended end. Each car in the Talgo train set has one supported end and one suspended end, except for the baggage car. Each rolling assembly is joined to two cars through upper and lower guidance arms, shown in yellow. The guidance arms serve as the primary attachment of the rolling assembly to the cars. However, they also position the wheels on the rail as the train moves along. The Talgo Series 6 was designed to International Union of Railway Design Code 566. The code includes several design standards, much like the standards here in the United States. The car body is designed to withstand static compressive loads of about 450,000 pounds at the coupler level without permanent deformation. The end walls require strengthening by anti-collision pillars. However, no structural strength requirements are prescribed. The operating approach of the Talgo train set places unoccupied cars at the front and rear of the train set. The power car and the baggage car are designed with collision posts. There are no collision or corner posts as part of the structural design of the individual passenger rail cars. As mentioned earlier, this train set was constructed before the 1999 final rule for passenger equipment safety standards. The final rule requires all passenger cars in use or on after November 8, 1999, have a minimum static end strength of 800,000 pounds. The rule also required each end of the passenger cars to have full height corner and collision posts, an anti-climbing mechanism between each car, truck-to-car body retention strength requirements, and car-to-car coupler strength requirements. The static end strength was the only requirement applicable to existing equipment. The others would be phased in as new equipment was ordered. In its 1999 final rule, the FRA said they were concerned with the level of safety of passenger equipment designed to European and other international standards. This was because train sets in Europe did not meet the structural standards common in the United States, and FRA believed that the adherence to such standards contributed to a high level of safety. Codifying these standards was FRA's approach to assure that a high level of safety was guaranteed when operating trains in the commingled environment with heavy freight trains and numerous grade crossings, specifically if the European train set became desired for use in the United States. Grandfathering is a provision in the regulation that allowed a railroad to petition the FRA to permit the use of rail equipment not meeting the 1999 safety requirements. The petitions submitted were required to include detailed drawings, material specifications, and engineering analysis sufficient to describe the performance of rail cars with non-compliant static end strength in a collision. Amtrak petitioned the FRA to grandfather the use of the Talgo Series 6 because the train set did not meet the required compressive strength of 800,000 pounds. FRA granted preliminary approval in September of 2000, subject to certain conditions. One condition required cables to serve as additional components to mitigate the separation of the car bodies and the rolling assemblies. The original design before the modification included 2 vertical cables, shown here in green. The modification that was done added straps affixed around each of the 2 tower supports connected to the end wall of the supported end of the car body, shown here in red. There are also straps connecting the end walls of the supported and suspended ends of the cars to the rolling assemblies, shown here in orange. The FRA established they must determine that if, in the absence of compressive end strength, causes the equipment to fall short of the performance that would be expected of equipment having the required end strength, so that its use was in the public interest and consistent with railroad safety. The central purpose of buffed strength is to ensure adequate compatibility among units of rolling stock used on the general railroad system with respect to collision risk. The FRA reviewed the petition and all available information and concluded that Talgo Series 6 could be expected to operate safely on the basis of moderate energy events. The FRA did express concern regarding the predicted performance of the train set in high-energy events. FRA said that the Talgo train set was expected to experience a greater lateral displacement than conventional equipment, and articulated connections were expected to fail. With the failure of the articulated connections, in the absence of compressive forces, the suspended ends of the car bodies would be free to fall to the track or the surrounding terrain without support and with unknown results. Greater lateral displacement of the passenger units would create a greater hazard of secondary collisions by fouling an adjacent main line or impacting with a bridge structure or abutment. As was predicted, the articulated connections failed in a high-energy event. When the articulated connections failed, the unsupported ends of the cars fell to the track, resulting in complex and uncontrolled behavior, which led to secondary collisions after they derailed from the tracks on which they were traveling. The outcome resulted in severe compromise of passenger car body structures, collisions resulting in the loss of survivable space and side passenger window failures. Altogether, these outcomes resulted in several passenger ejections, injuries, and 3 fatalities. In this derailment, the separated rolling assemblies caused 3 fatalities and several injuries, which likely would not have occurred in compliant passenger rail cars supported by trucks designed to remain attached. Based on the failed articulated connections, the lack of compliant structural protections of the Talgo Series 6 car body, and the demonstrated behavior of this train set in this derailment, staff believes that this train set does not provide adequate protection to passengers in the event of a high-energy derailment or collision. In severe or high-energy accident, the train cars often depart from the tracks and into adjacent surroundings. The physics of the train during a derailment or collision and the following forces from the trailing cars are the dominant contributor to this behavior, which typically results in jackknife individual train cars and separation into the surrounding environment. Once in the surrounding environment, the train cars are exposed to nearby trains, automobiles, and rigid wayside structures. The crashworthiness of the individual cars must be able to resist to some degree the forces they will be exposed to from secondary collisions. The Talgo Series 6 train set lacks those structural protections afforded to riders traveling in passenger rail cars that meet the current U.S. safety standards and is structurally vulnerable if it is involved in a high-energy derailment or collision due to its lack of crashworthiness protections and is at risk to severe and catastrophic loss of survivable space. Lastly, there are no provisions in the grandfathering rule that allow the FRA to continuously monitor grandfathered equipment. The Talgo Series 6 is the only train in the United States that has an approved grandfather agreement that allows it to operate with car body end strength that does not meet U.S. requirements. This investigation determined that the risk of allowing the grandfathering provision to remain in the regulation is an unnecessary risk and is not in the public interest nor consistent with railroad safety. Staff has made recommendations to address these issues. Thank you. Now Ms. Harley will discuss survival factors.
Good afternoon. The survival factors presentation will examine train occupancy and injury, the use of compartmentalization for occupant protection, and the inadvertent rotation of train seats that adversely affected compartmentalization and passenger egress. This presentation will discuss the lack of emergency lighting and high-performance photoluminescent signage that hampered passenger evacuation and the rescue efforts by emergency responders. The presentation will also examine the highway users that were involved in the derailment. Lastly, I will discuss the emergency response and the interoperability of the communications system. There were 83 occupants aboard Amtrak 501 at the time of the derailment. This included both passengers and crew members. 42 occupants sustained injuries and 3 were killed. 31 occupants were uninjured. The injuries to 7 passengers could not be determined because staff was unable to obtain medical records or interview these individuals. 7 passengers were ejected. 2 of the ejected passengers sustained fatal injuries, and 5 were seriously injured. 3 passengers were partially ejected, and all sustained serious injury. On the left is a photograph of train car 7424 at final rest on the interstate. 5 passengers were ejected out of this train car through the open window spaces, as indicated by the red arrow. Train car 7421 came to final rest on top of 7424. On the right is a close-up of 7421. The arrow indicates the opening created by the separation of the train cars. Through this opening, an unsecured, empty child car seat was ejected out of the car. This is also the location where a passenger was partially ejected. Train cars do not possess occupant restraint systems. To protect passengers, railroads depend on compartmentalization to provide occupant protection. The goal of compartmentalization is to prevent or mitigate serious and fatal injuries by minimizing the distance an occupant can travel within the car, and by preventing ejection from the space. During the derailment of Amtrak 501, the occupant protection was compromised by the structural damage to the rail cars that created openings through which passengers could be ejected, and by the unintended rotation of the train seats. 6 train cars experienced the inadvertent rotation of the car seats. The photo on the left shows the rotated seats in train car 7423. As a result of the rotation of the forward row of seats, the passenger located in the seat behind was struck and propelled into the train car window. This passenger sustained serious injury. On the right is a photo showing the rotation of train car seats in car 7420. Despite the lack of significant damage sustained by this train car, several rows of seats rotated. The rotation of these seats reduced the width of the aisleway used by the passengers to evacuate the train car and first responders during rescue efforts. This photograph shows a seat row that inadvertently rotated during the derailment. The arrow shows the location of the seat latching mechanism that is used to secure the train seats in place on the adjacent seat row. Several passengers reported that following the derailment, they were unable to evacuate the train using the loading doors. The passengers advised that there wasn't enough light in the train cars to assist them in their evacuation. 2 passengers reported that after numerous unsuccessful attempts to open the loading doors, they eventually self-extricated through one of the train car windows. The examination of the train car involved showed that passengers had pulled down the red levers, similar to the one indicated by the red arrow. However, it appeared that the passengers failed to pull the lower release mechanism shown here by the yellow arrow. Both passengers reported it was too dark inside of the train car, and neither reported seeing the instructions posted above the exit controls, as shown by the red arrow. Though the required signage was found in all of the train cars, none of the signage possessed the required high-performance photoluminescence that would have permitted the passengers to see and read the instructions for the exit door controls in the low light and no light conditions. During the derailment, several highway vehicles were damaged and the occupants injured by the derailed train cars, detached train equipment, and debris thrown onto the interstate. 4 vehicles were struck by derailed train cars that entered the highway. 1 vehicle was struck by 2 different train cars. In addition, several vehicles were struck by or collided with the detached rolling assemblies from the rail cars. In all, 8 highway vehicles with 10 occupants were involved in the derailment. 6 vehicles sustained extensive damage and 2 sustained moderate damage. 8 of the occupants were transported to medical facilities for treatment, and 6 sustained injuries. This map shows the area of the derailment of Amtrak 501. Interstate 5 is the roadway seen going east and west. The military installation, Joint Base Lewis McChord, JBLM, which is located within Pierce County, occupies the area on both sides of the interstate. Under a Memorandum of Understanding, MOU, the military base, JBLM, provides the primary fire rescue emergency response for this part of the county. JBLM operates its own Emergency Communications Center under the Department of Defense and is independent of the Pierce County Emergency Communications Center. 2 miles south of this location is neighboring Thurston County. This slide shows the various agencies that responded to the incident. JBLM conducted emergency operations in accordance with the National Incident Management System, NIMS, and the Incident Command System, ICS. On the day of the derailment, JBLM requested mutual aid assistance from the adjacent counties. Units from both Pierce County and Thurston County responded. The duty chief in Thurston County authorized the upgrading of his county's emergency response. This resulted in an overwhelming number of emergency responders being sent from Thurston County, despite the incident occurring within Pierce County. The Department of Defense Communications Centers operate on a 450 megahertz radio frequency. This results in an incompatibility with the emergency communications centers of adjacent civilian agencies. Previous attempts to mitigate the lack of interoperability between these systems were unsuccessful. During the incident, JBLM set up a unified command that required command officers from adjacent jurisdictions to respond to the command post to conduct face-to-face communications that would require relaying by individual agency radios to the units in the field, or by using runners to deliver instructions in person. This slowed the communications process, resulting in emergency responders conducting self-initiated rescue operations, failure of units to receive important operational instructions, and the lack of timely, efficient communications between JBLM, fire, and law enforcement agencies on the scene. In summary, the following safety issues were identified. The need to reevaluate the effectiveness of compartmentalization for occupant protection, especially for those passengers that fall outside of the current testing range. The need to reevaluate the effectiveness of securement mechanisms to prevent the inadvertent rotation of train seats and ensure that securement mechanisms are properly engaged prior to passenger service. The development of policies regarding the safe transportation of children in car seats. The need for adequate emergency lighting in the event of a loss of power, and the effectiveness of current communication systems and deficiencies with the interoperability caused by incompatibility between the Department of Defense and civilian communications. Staff has proposed recommendations in these areas. This concludes my presentation. Staff is ready to answer any questions. Thank you.
I want to thank you all for very good presentations and most importantly, a very good and thorough investigation. Thank you very much. We'll begin with the board member questions and Vice Chairman Landsberg.
Thank you, Mr. Chairman. How many jurisdictions had safety responsibility oversight for the Point Defiance bypass? It seems like there was an awful lot of paper mitigation, but not much in the way of operational effectiveness.
There were multiple agencies involved. I count 4. And ultimately, that responsibility for safe operations and a project that's ready for those operations lied with Sound Transit.
There was a statement made that there was a report required some safety information to be submitted to FRA, and yet they said they had no responsibility. Why would you submit a report to somebody like that and not have any input on it?
That's a great point, and that report was a requirement of the grant.
But it had no operational significance.
It had operational significance to the management of safety on the project. But from an oversight perspective, the FRA's regulatory authority does not permit a comment or a revision to that document.
That seems like a bit of an oversight that you require something and then not have any ability to weigh in on it. On the highways, I have more experience there. There are relatively few areas, in fact none that I know of, where the speed limit changes so precipitously, in this case from 79 or 80 miles an hour down to 30 miles an hour without some sort of transition, which allows drivers some time to adjust. Is this practice of rapid speed change common on the railroads?
These rapid speed changes do exist on the railroad, and they are not uncommon in the industry. And we've actually seen some accidents in Chicago about 12 years ago where a train was operating 80 miles per hour and needed to reduce its speed to 30 miles per hour for a crossover. It failed to it failed to see the signal indicating it should do so, and there was a high-speed derailment. Afterwards, the railroad removed that crossover. There are some strategies to make this less dramatic speed change. For instance, in Great Britain, they use a step-down speed change. If a train is going 79, it may not be, they may have a 79 to 60 to 40 to 30. So it's a speed lowered in increments. And that's something that I know that our rail industry is aware of, and I do hope they examine that.
Is there any reason why they haven't chosen to adopt it? I mean, it seems to make very good sense that rather than just having one speed sign or to warn you that something's coming up, it would make a lot of sense that if you missed the first one, maybe the second or the third would wake up the crew.
Right, I agree that it does make sense.
Could you explain to me a little bit about what a crew focus zone is?
So the crew focus zone is an area of increased vigilance, requiring crew member communication, mainly between the conductor and engineer, in advance of an upcoming speed restriction.
And so on the Point Defiance bypass, there was only one crew focus zone that was identified, and it was not at milepost 19.8.
That's correct, sir.
Why was that?
There was an oversight in the internal process and the document review process to ensure that that second timetable, that operating document, was actually up to date and accurate at the time of revenue operations.
So let me understand, there were 4 organizations that were responsible for the safety oversight, and this seems like a rather important aspect to it, and nobody caught it?
Correct.
No further questions, Mr. Chairman.
Thank you, Vice Chairman Landsberg. Member Weiner.
Let me start by asking if we could show slide number 4. Because we've had several conversations in the hearing several months ago, as well as in the presentations today, that talked about who was responsible for safety. So there are 7 boxes here. Which boxes are responsible for safety?
Every single box.
Every single box. Which ones are immediately responsible for operational safety?
Sound Transit had the ultimate responsibility to ensure that that project, the Point Defiance bypass, was safe and ready for revenue operations.
So in terms of decisions being made that reflect safety, Sound Transit is responsible for those decisions?
Through their safety certification and verification process, yes.
So with regard to safety, what role does Amtrak play, for example?
Amtrak, as the railroad of record, has a responsibility and a duty to ensure that what the host is providing them is safe for operations.
So to speak, Sound Transit is the owner of the railroad,
That's correct, they are the host.
but who owns the equipment?
WashDOT.
Is it unusual to have a state entity owning equipment?
It's not unusual to have multiple arrangements such as this one.
Now, we learned in the pursuit of safety in general or in commercial aviation that safety management systems are critical to the kind of safety level we get. A major part of the safety management system is risk assessment, risk management. Who does the risk management on this assemblage of parts, of organizations, all interconnected?
That is an excellent question, and as staff references in the report, there was no entity responsible for the coordination of all the activities.
So there was no risk assessment in terms of deciding to start revenue service on this route?
The risk assessment process for the project was managed by Sound Transit. However, the operational components such as pre-revenue testing and an operating hazard analysis, those were not completed as part of Sound Transit's internal process.
And just for those people who are not really familiar with risk assessment, what are the major components of risk assessment?
The identification of hazards, the mitigation of those hazards, and then the validation of those mitigations.
So it's the hazard and as well how often that hazard's likely to be encountered, probability.
Probability and severity, absolutely.
So what you would like to find is those conditions that have little severity and don't happen but very seldom, but on the other end, those that are catastrophic and have some likelihood of occurring. So in this case, going from 80 miles an hour to a 30-mile curve, those numbers seem to be familiar to me. More than one accident has had that kind of signature. How would that be mitigated in this case?
It was not factored into the decision-making process when establishing the mitigations. What was left was a procedural control, the timetable. And in the accident, the most recent accidents, we've seen that procedural controls do not work.
Procedural controls leave it up to the operator and the operator's memory and recollection of what they're supposed to do.
Correct.
Thank you.
Member Weiner, thank you very much. Member Hamady.
Mr. Hiller, what is the FRA's mission?
Member Hamady, in short, the mission is to enable the safe, reliable, and efficient movement of people and goods now and into the future. And
Correct.
I'll just summarize it.
And I have, so Title 49 of the U.S. Code, Section 103, says that in carrying out its duties, the administration, meaning the Federal Railroad Administration, shall consider the assignment and maintenance of safety as its highest priority. Safety is its highest priority, not efficiency, not movement of trains, safety. Recognizing the clear intent, encouragement, and dedication of Congress to the furtherance of the highest degree of safety in railroad transportation. So I'm a big believer in you have to go back in time to figure out where you're going in the future. So I want to talk for a couple of minutes about the grandfather clause, and I absolutely refuse to call it the grandfather clause. It wasn't a grandfather clause, it was an exemption. You got an exemption to the passenger rail car crashworthiness standards, so that's how I'm going to refer to it. There were a lot of, I went through the FRA docket back to 1998, and there were a lot of failures on the part of everybody, of course. But when you're looking at risk analysis and you're determining how to mitigate your risks, you have to make some assumptions and you have to look at certain scenarios for testing. And so when Amtrak filed a exemption request or a petition with FRA, FRA had Amtrak do some studies. There was LTK, there was Arthur D. Little, and a number of others. Volpe also did a study. At the time, they looked at certain things. They looked at train-to-train collisions, they looked at grade crossing collisions, collisions with heavy vehicles, and accidents in yards and station areas. What's missing?
In my opinion, what's missing is overspeed derailments.
That's right. Overspeed derailments, and I will tell you, during the shutdown, I read all 150 accident reports that NTSB determined were PTC preventable. Those accidents were PTC preventable, and I can't tell you how many were overspeed derailments. So you know overspeed derailment is a significant safety concern. You certainly can't study every single scenario, but when you know that one is a potential serious problem, you look at it, especially when repeatedly you are concerned with high energy events. Which then takes me to the next point, that they looked at crashes at 25 miles per hour, 40 miles per hour, and 50 miles per hour, but on this track it was 79 miles per hour, and Amtrak petitioned the FRA in 2002 to go 110 miles an hour. And so I think railroaders would say if you stretch out the track, you look at 10 miles an hour here, 15 miles an hour there, it averages to maybe 50. But the fact is FRA was concerned about high energy events. There were other assumptions that I think were faulty. The Talgo train was compared to an Amtrak conventional train, which were two entirely different trains. So this proceeding moves forward. FRA says they have significant safety concerns, and in their initial decision, they say, during discussions with Amtrak and Talgo prior to submission of the petition, FRA staff engineers focused on several areas of apparent weakness in crash scenarios that were capable of being readily addressed through design modifications. These limitations had to do with the support of the car body at the end where it was suspended, by weight-bearing bars and resistance to override, the retention of the bogie, which included the rolling assemblies, and suspension towers in an upright position associated with the units they support, and keeping the articulated units together after breakage of the articulated connection. Addressing these needs will help ensure that the train set remains upright and in line, that loads are efficiently transferred down the length of the train, and that the bogie, the rolling assembly, does not become a missile capable of entering the occupied volume. Can you pull up slide 71? There's the rolling assembly and the towers. So essentially, an FRA in 1999 predicted exactly what was going to occur. How many rolling assemblies detached?
A total of 5, ma'am.
How many articulated connections were broken?
A total of 6, ma'am.
So they knew exactly what could be coming, and then even knowing that, they put together some, I'll say, Band-Aids for mitigating those hazards. And then on top of that, and I know I'm a little over time, if you could give me just a few more seconds, on top of that, this grandfather clause, this exemption, applied to, can you pull up the map real quick? The map of the route. It might be slide 2 or 3. Okay. There we go. So it applied to this green, the exemption applied to the green route, right? The Federal Register notice on this exemption said that if Amtrak wanted to apply this approval to any other route, they had to reapply to allow that approval on the other route. So they reapplied in September of 2017, 3 months before the accident, to FRA, right? To apply that exemption from the green route over to the Lakewood subdivision. The crew started qualifying on the route in November, and then 4 days before the accident occurred, they approved it with no documentation. No documentation, no FRA analysis, and what the letter actually said was in the approval, FRA asked for, do you have the letter? Can you read what they asked for? They asked for these after approving the start of service.
Yeah, let's wrap it up here, and then you can come back
Go
for the
ahead.
second round.
Not later than 30 days from the approval letter, Amtrak must provide a written summary of the test results from the new Lakewood subdivision. So in short, what they were asking for is the similar type of analysis that were done on the other routes that they had to demonstrate the car would comply with safety I believe this would have identified the curve.
It would have, because
Short
it
and
asked
sweet.
for any changes
Yeah.
in the risks. So thank you very much.
Thank you, Member Hamady. Let's talk about the engineer. The engineer was described as being, by the road foreman of engines, as being very competent, conscientious, no reservations about him. He went up to Seattle the night before to get a good evening's rest. I noticed that in the interviews there was some training going on, and he, on his own expense, got a hotel because he wanted to be rested for the training. He knew about the curve. In his interview, he said, and I quote, "We all hated the curve. Everyone hated that curve. Everyone was concerned about that curve." And yet, they made a mistake. And you know what? Somebody a lot smarter said, "To err is human." We all make mistakes. And so we have to allow for that mistake and put in place redundancy so that when somebody does commit a human error, that mistake is trapped before it becomes consequential. And in this case, the backstop would have been positive train control. but that wasn't there, and it should have been. It would have been easy for us just to complete this investigation. We could have done it a few days after the accident, because we knew that that train went around that curve at too fast of a speed. We could have closed it right then and there. But in fact, we didn't, because by doing a very thorough investigation, the NTSB, your staff, has identified failures up and down the line. Because as I said in my opening statement, the engineer was set up to fail. He was let down by Amtrak, who provided insufficient route familiarization. He was let down by Amtrak in the insufficient training in the charge of locomotive that he had only operated a few times. He was let down by Sound Transit, who provided ineffective mitigation of the hazardous curve. By Washington State Department of Transportation, by their decision to start revenue service without ensuring that the risk had been sufficiently mitigated. And by the FRA, who, as Member Hamady just pointed out, allowed cars to be used that did not meet the regulatory strength standards. And as Mr. Hiller pointed out, those 3 fatalities more than likely would not have occurred had they been in conventional rail cars. So I am pleased that our staff took a deep dive. We looked at the entire system, not because we're here to blame anybody. We're not in the business of blame. We're not here apportioning blame. By looking at the entire system, that's how we identify deficiencies that can be corrected. That engineer will probably never make that same mistake again for a lot of reasons. But we can, through a very thorough investigation, identify deficiencies in the system that can be corrected. So I know this has been a very long and at times frustrating investigation, but I want to thank you for your dedication to not just stopping the investigation at the identification of the engineer's error, but by looking at the whole system, and through that we will make our railroad system safer. So with that, I'll just yield the balance of my time and go back to the second round of questioning, and why don't we finish this second round of questions and then we'll take a break. So how's that sound? So Vice Chairman.
Thank you, Mr. Chairman. I understand that the conductor and the engineer were both new to the route, and both were in the cab of the locomotive at the same time. In the aviation world, as Chairman Sumwalt will recognize, we have a terminology for that. It's called green on green, which means that you have 2 new people in the front end operating the vehicle. And we've learned in the aviation world that's a very bad combination. And I think we'll get perhaps more into the training of the engineer or lack thereof. This engineer was barely qualified, if he was qualified at all, to do that because of the failures that were manifested up and down the line. But not only that, one of the statements was made, explained to me, what's the role of the conductor in the front end?
The conductor is a second set of eyes. His activities will include calling out signals along with the engineer. He'll handle radio communications with the dispatcher and train to train. And he's really in charge of the overall safety of the train.
So to use the aviation comparison, he would be considered the captain, if you would, and the engineer is sort of the first officer? If you make him responsible for the overall operation of the train, somebody has to be in charge?
Fair enough, but just to be specific, he doesn't have the skill set to operate the train, but nonetheless, as you said, he is responsible for the overall safety.
So this conductor was not yet qualified to be able to do the things that you stated of calling out signals and mileposts because he was not familiar with the route. Is that correct?
Well, let me distinguish between certified and qualified. He was a professional conductor. He had been operating as a conductor for 5 years. This process, part of the process is to get qualified on a specific territory. So in other territories where he was qualified, he acted as a full conductor. Now he was in the process of qualifying on this new territory. So he was on the head end to get familiar with the characteristics.
Does this kind of situation happen often where you have two brand-new crew members who don't know the territory? It strikes me very much of this is the blind attempting to help the blind.
Yeah, and unfortunately, this was sort of a perfect storm. We have a brand-new territory that's really new to all of the Amtrak crew. So there weren't many people who we could say had much experience at all.
But there were road foremen or supervisors who had made considerable trips and were quite a bit more familiar with the territory. Is that correct?
Well, not necessarily quite a bit, but enough for them to feel qualified. But they hadn't been operating for years, just since the line was starting to open.
Was there, it seems to me there was a phone call or conversation between the road foreman and the engineer prior to departure that said, now remember the curve. Is that correct?
That's correct.
So it would seem like it would have made better sense to have that person in the front end because he was familiar and cognizant of what's going on, and maybe the qualifying conductor is also up there, but you have completely eliminated the whole concept of the backup or second set of eyes. They're both so situationally unaware, which is why in the aviation industry we stopped doing this, and yet this seems to be standard procedure for the railroads?
As a matter of fact, the same road foreman who called him was planning on riding along, beginning with the first northbound trip that day, which would have been the second overall trip. He was located in Portland, so it would have been more convenient for him to have started south, worked his way up, and continued riding with other crews. He recognized there was value to that, but there was no one on the first train.
I'm just amazed at the amount of failure that goes along here under so much emphasis is placed in the operational sense or lack thereof of safety. We have 5 or 6 or 7 different organizations that all say safety is their primary responsibility, and yet nobody seems to be responsible. And it just flows all the way throughout the entire operation here, from the very top management down to the lower levels, where you have a supervisor who says, remember the curve, but yet they don't seem to have anybody who's capable of backing him up in the front of the train. Thank you, Mr. Chairman.
You're quite welcome, Vice Chairman. Member Weiner.
Just to follow on the Vice Chair's discussion with regard to crew members, there's a process in aviation called crew resource management, and the starting premise is that the airplane in this case is to be operated by a crew as opposed to a single pilot and a hot spare. Was that process, that philosophy applied in this case?
Crew resource management is part of Amtrak's training program.
Amtrak didn't make all of the operating decisions, right?
I'm sorry, in what specific regard in terms of operations? Amtrak developed the qualification programs and how they were going to be trained.
So what's the relationship between Amtrak and the sound transit?
So Amtrak participated in some of the initial PHA activities. But as I mentioned before, because there was no pre-revenue testing period that occurred, and there was no operating hazard analysis that was completed, Amtrak was missing from that final ramp up to initiating revenue service. That's where that interaction should have been hyper-focused.
Okay, so that was an interaction outside the locomotive. My apologies to interrupting you, Dr. Jenner. You were talking about crew resource management and the application in this case.
I think there was opportunity to apply crew resource management principles, and that is part of the recommendations. The attitude going in was for the qualifying conductor to take a passive role, learn as much as he can. But I've seen from other crew resource management programs in aviation, in the marine industry, and in rail, that there's a belief that even the most inexperienced person can have a role in safety. And that can be as simple as, well, being a second set of eyes to look out, to understand that this is new to both of us. Let's work together to identify signs, even if you're not qualified on the territory yet. But also, there was a period of time, as I described, that the engineer was confused with the alarm, and the confusion is a cue that an error chain can be developing, that things are starting to go wrong. And this needs to be identified and addressed. If necessary, you slow or stop the train. But again, this is the crew working together and understanding all that is going on at that time.
So you said even the most inexperienced crew member can provide some value. But there certainly is some expectation of what the other crew member is going to provide.
In this instance, this qualifying conductor was expected to call out the signals and handle the radio operations. So he was expected to and prepared to handle some of these operations. But what I think the crew resource management goes beyond just performing operations. It's trying to help establish overall safety and a recognition and handle ambiguous situations and take actions as necessary.
So in this particular case, there were an alarm at the wrong time. There were at least two signals, two signage opportunities that were missed. And the conductor, who is basically the second, if you will, in this particular hierarchy, missed providing any support with the engineer dealing with the enunciation that he hadn't encountered before.
I think the latter, because he wasn't qualified on the territory, he had never been over it before, there's probably not an expectation that he could recognize every sign the way a qualified person could. But what you just mentioned, the enunciation of the alarm and the confusion that it brought on, I think that was an opportunity to say there's something bad going on at this point.
Thank you.
Thank you, Member Weiner. Member Hamady.
Thank you. Can you pull up slide 50? Okay, so I want to talk about, so when FRA approved the exemption for the use of the Talgo train sets, they required 3 sets of mitigating measures, which included the addition of these safety cables, or straps, in red, and then also in orange below, correct? And what was the point of that?
So you see the orange cables down at the bottom. Those cables were in essence straps, and the straps' purpose was to keep the cars together should the articulated connections fail or add to the overall ability to prevent car-to-car separation. And the red was to retain the rolling assembly to the suspended end to help retain the rolling assembly to the supported end of the car.
And they were connected to a metal ring in the back of
They are
those columns, correct?
Yes, ma'am. They're connected to the end wall and by means of a little ring.
And they were zip tied in some fashion to keep them up, I guess?
In some cases, zip ties were observed, and this was, the purpose of the zip tie was to prevent unnecessary movement to keep the strap from abrading.
But the zip tie, did the zip tie have any role in contributing to?
Oh, no.
Oh.
The zip tie was just really
There was no-
to keep the strap from.
But there was no movement there between the zip tie and the strap, correct?
Oh, yes, there would be some
Yeah,
movement.
that's what I mean.
Yeah, sure. And that was something that the investigation looked at very closely, and of the straps that we sampled from the accident train and from exemplar trains, the straps all exhibited behavior of wear and fraying, appearing to have some obvious exposure damage from ultraviolets,
Great. And
environmental conditions.
thank you. And the type of straps we're talking about here that were used in the train sets are similar to lift straps that are used in workplaces, correct?
Exactly.
Or work sites, which these straps have strict tolerances, and they're governed by OSHA standards. And I guess I would ask, given the important role of the straps and how they played into the safety of the train sets, would it be reasonable to assume that the straps would be inspected, maintained, and replaced accordingly?
Yes.
Okay. So while Talgo did not have the data on strap replacement for the lifespan of the train sets, they stated that over the past 3 years, they have replaced 2 straps. Back of the envelope math by my staff has approximately 330 straps in the 5 train sets that were exempted. 6 per rolling assembly, 11 assemblies per train sets, and 5 train sets that were exempted. Even over 3 years, one would expect more than 2 out of 330 would be replaced. So prior to the accident, did the maintenance plan for either Amtrak or Talgo specifically address the straps?
No, there wasn't a specific maintenance plan. It was just kind of covered under the general practices of periodic inspection, and if there was an observed condition that needed to be addressed, it would be. Typically with these types of straps, one would expect that there would be periodic inspections to include scrutiny and also load testing. You say that these straps are used by OSHA. Well, in an OSHA world, a strap that's designed to lift objects using a crane or other such device would be required to be periodically load tested at some interval.
And our testing showed that the strap fractured at loads of, 10 to 50% of their braking force, correct?
Mr. Fox, could
No,
you
Dr.
comment on
Fox,
that,
sorry.
please?
That's correct. 10 to 50% of the sampling of 12 straps that we took, both from, 6 from the accident train set, and then another 6 from an exemplar train set.
Okay, thank you.
Thank you, Member Hamady. Dr. Jenner, when did the engineer qualify on the Charger locomotive? It was just a few days before the accident trip, is that correct?
He qualified on the territory
Okay.
just a few days
All
before.
right, when did he qualify on the actual Charger locomotive?
Well, there was training in the previous summer, which
That
was
was ground training.
ground training. During the runs over the territory, they were on sometimes Charger locomotives and sometimes others.
Yeah, but I'm not going to count the fact that he's standing in the locomotive cab watching somebody else watching it. I'm not going to count that as training.
Right.
The only time that he would really actually have hands-on experience, that's what I'm talking about.
Right.
And the page 38 or the 34 of the report says he operated the Charger locomotive on some, but not all of the qualification rides, but he only had 3 qualification rides. So how many times had he operated this Charger locomotive prior to December the 18th?
It was either 1 or 2 times.
Yeah, okay. And that's kind of the point I'd like to make here. So can you explain, because you did a very nice job, the staff did a nice job on it, on page 140 of the report, explaining how the unfamiliarity with this locomotive could likely set up the situation that existed that day?
Absolutely. As I mentioned in my presentation, he had other locomotives have overspeed alarms. This was a newer locomotive with a newer version of the overspeed alarm, and it provided a little more detail than the previous generations. However, that detail, one particular light about the traction control, he had never seen before. And that's good information to have if you've been exposed to it before, but he wasn't. So he was trying to make sense. Why is this light on? What does it mean? And he appeared confused because of that.
So I think that's a really important point. I'm going to read from his interview. He said, well, in addition to being more focused on the gauges, when you look at the gauges, you don't see out the window, which is very different from other locomotives. You have to take your eyes off the track to look at the gauge. So in other words, he's basically saying that because he was not that familiar with this locomotive, and by the way, he only had about 60 seconds in the seat before leaving that morning because of a maintenance problem. So he's got that going on. And then he's having to look at the gauges more, so therefore he's not looking out the window as much. Now he hears an alarm that he's not familiar with, and the report basically says, his prolonged attention on the control screens at the expense of looking outside the cab minimized his opportunity to scan the territory and identify his location or potential hazards. Moreover, his focus on the alarms likely affected his sense of the time and distance his train traveled. So, I think that the fact that he was not given adequate familiarization rides, opportunities, hands on the stick, sort of training, I think that was a very significant factor in his loss of positional awareness. Do you agree?
I do agree.
So we talked about these alarms. Basically, an overspeed is a series of beeps and illumination of lights emanating from the control panel. How is this different from other engines that he may have operated?
Two other locomotives that this engineer would have been familiar with would have been a GE type and an EMD type locomotive. One of them would have a yellow square at the top of the screen stating overspeed. Another one would have a red LED on the speedo in front of them. Both these locomotives were built and put into service prior to the standard coming out.
Yeah, so basically they were different. Are there standards for alerting features on locomotives?
There are standards, and this new Charger locomotive meets those standards.
Okay. And I think we said in the report that page 139 said that he moved his scan. We could see this from the inward-facing video that he moved his scan inside for the next 20 seconds after receiving this alarm. That's the point I wanted to make. Unfamiliarity was a significant issue here. Okay, we'll go to we said we'd take a break. Let's take a break until 3:05 by that clock right there. We're in recess. We'll get started in about 1 minute. Okay, we're back in session. We'll begin with another round of questions. Vice Chairman Landsberg.
Mr. Chairman, thank you. For the Point Defiance bypass to be opened, was positive train control a requirement on this route?
No.
So we can open up new routes and not have positive train control on it?
Let me clarify my initial answer. Back in 2014, when the initial PHA was done, the deadline for PTC was 2015. So that's why you see positive train control on those initial PHA documents. So there was a plan to include PTC.
Okay, so this was all laid out with the idea that PTC was going to be part of the whole process.
Correct.
But PTC was not operational when they started service.
That is correct.
Why?
The
PTC was not operational at the time because there basically were three entities to getting it fully deployed. One of them being Amtrak, which was responsible for having all the equipment on the trains. Sound Transit was responsible for having all the wayside equipment and the software out in the field. And Burlington Northern Santa Fe was responsible for having the back office software, which involves the dispatching of trains and the movement of these trains in the area. While some of all three parts were done, the back office software was not complete, so there had been no testing yet, so there couldn't be any deployment of PTC at the time.
Now, I recall reading in the report that it was said that there was a unacceptable risk based on this corner without PTC. Is that correct?
That is correct.
But PTC was not operational.
Correct.
So we have an unacceptable risk by their own definition, and yet we're operating. Now, how does that work?
That is the flaw in the certification process.
I'm not quite sure how to respond to that because it's almost a catch-22 of we have something that's unacceptable and but we're going to go ahead and operate anyway because it's unacceptable. This makes no sense to me whatsoever, and there must have been mounds and mounds of paper rules with multiple people responsible for making this a safe operation, and yet nobody was responsible. Is that a correct assessment?
Yes.
The FRA, as Member Hamady has pointed out, in their authorization says that they are to operate or oversee the operation of railroads to the highest, specifically
Highest degree of safety.
Thank you, the highest degree of safety. And yet they seem to be able to grant exemptions for train sets and route operations and things of all sort. Why does that happen?
Well, first I'll speak to the grandfathering provision that did reside in the Part 238. So when the rule was published, there was an element that existed in the rule that was basically a pathway that allowed equipment that did not meet end strength requirements to be approved for operation. So regarding the positive train control question, I think because the rule requiring the installation of positive train control gave the operator until 2018, or in some cases 2020, as in this case, the FRA did not compel or require PTC to be installed in this curve or on this track prior to its inaugural run.
But didn't you initially say that PTC was required nationwide in 2015?
Real quickly, initially you had the Chatsworth accident on September 12, 2008. The Rail Safety Improvement Act, implemented on October 13th of 2008, said PTC had to be installed and running nationwide on anywhere there's freight trains, passenger trains, or toxic chemicals by December 31st, 2015. Railroads petitioned Congress, and it's Congress that set these deadlines because it's a congressional law. The railroads went to Congress and said, we're not going to meet it. Congress allowed the deadline to be extended to December 31st of 2018. And if they meet certain benchmarks, then they could get a 2-year extension to 2020. And in the case of Burlington, Northern Santa Fe, and Amtrak, as soon as these dates went into effect, they petitioned the FRA, got the waiver exemptions, and aren't required to have it implemented till December 31st of 2020. But as they said earlier, when the hazard analysis was done, they made FRA made the decision based that PTC would be in effect, therefore the speed limit would be mitigated. Where the ball was dropped is when they got the extension, no one revisited it.
Thank you.
Thank you very much. Member Weiner.
The railroads have some pretty extensive operating rules, right?
Yes, sir, they do.
And those rules are assumed to be followed, although as the chairman said during his opening remarks, we assume at some point that the rules are not followed, that the crew member is going to do what he's not supposed to do, and then how is that error going to be trapped and recognized? Now, we've had several accidents where, and in most cases, my recollection kind of says they were single crew member accidents, but where a turn was entered at a higher speed than was the limit. Now, most people have some sort of display in their automobile which shows where they are geographically. Why hasn't that idea caught on with the rail community?
So staff has recently become aware of a pilot project at Amtrak that aims to put a movable map into the conductor's electronic device that's issued by the railroad. So that is in the testing phase, and we look forward to seeing how that rollout continues.
Now, would that be integrated into PTC at some point? Because some of the information is the same kind of information that is being incorporated through PTC.
I don't believe that there are any current plans to integrate that pilot project into PTC.
Is there any feeling for why the rail community is apparently less than enthusiastic?
Basically, after our derailment investigation of Amtrak 188, we did make a recommendation to require the railroads to develop procedures that would help the crew identify their locations, and display their upcoming route. And FRA's initial response was received, and they said that this recommendation required the development of testing of new technologies before it could evaluate its implementation to move forward and move on. But they did cite that there were reasons to not pursue this, cost prohibitive, what the benefits would really provide. And the communication went on. Jeff, could you add anything else to this?
Yeah, recently received a letter from FRA with regard to that recommendation, and they reverted to a Rail Safety Advisory Committee or some group of the railroads. They determined that, in their view, the technology was prohibitively expensive, of limited value. In their letter, they actually said the benefits of the recommendation were, quote, dubious, and that they absolutely, positively would not consider taking the action that we recommended in our 1632. And in the report, we are proposing that that recommendation be classified closed unacceptable.
I find that very interesting because the so-called glass cockpit in the aviation community, the decision to have a moving map display was a major decision, and as you talk to most pilots, they're would be devastated not to have a moving map display. As far as the technology being too expensive, well, actually, most of you have one on your iPhone, a moving map display, GPS driven. So it's essentially included in the price, but for $100, you can have a fairly good GPS. Have we given some thought to reiterating that recommendation?
It is, of course, the board's decision on what to do in this case, but the policy that staff follows in terms of recommending a classification of a recommendation is that when the recipient, in this case FRA, tells us in very clear, unequivocal language that they are not going to take the action and that they're not going to consider it any further, we close it. Most of the Department of Transportation modal administrations have the feeling that if they tell us they're not going to take the action and we keep it open, they're just going to ignore us.
All right, thank you.
Thank you, Member Weiner. Member Hamady.
Thank you. During consideration of the exemption that FRA was debating, they asked Amtrak to contract or examine installation or implementation of PTC and the benefits it would provide on the routes in question. And so they contracted with Arthur D. Little and found that for the Pacific Northwest corridor, PTC would reduce the risk of fatalities by 47% and the risk of injury by 30% if it was implemented. And then at a later public hearing in 2000 that FRA held on the exemption, they stated the safety improvements with the installation of PTC would be substantial. What they decided to do was install CTC on the line, which was centralized traffic control. And if I'm accurate, Mr. DePape, that essentially allows you permission to move into the next block through a signal system. It is not PTC. PTC addresses four things: overspeed derailments, incursions into work zones, train-to-train collisions, and what am I missing? Switches left in the wrong position. Overspeed derailments, meaning this one. So, one more time, Would PTC have prevented this accident, Mr. Hiller?
Yes,
Do you believe WashDOT, Amtrak, and Sound Transit failed in their responsibility by not requiring PTC to be implemented prior to initiating service?
I do.
And this is important because Sound Transit at the hearing, at the NTSB hearing in July 2018, said PTC is not federally mandated until December 31, 2018. And I think we need to be careful of falling into that trap because what the law says is by December 31st, 2018, not on December 31st, 2018. So it was the choice of WashDOT, well, really Sound Transit, and Amtrak not to implement PTC. PTC was around for a long time, at least in discussion and testing phases, and it wasn't until Congress mandated it that the railroads started implementing it. They could have done it sooner, and FRA could have made them. FRA said at our hearing that they couldn't do it. The problem is, if you look at the Federal Register notice for the Talgo train for the grandfather exemption, the Federal Register notice says if the petitioner has complied with the federal requirements and FRA finds that the proposed usage is in the public interest and consistent with railroad safety, the petition will be granted, and FRA may attach special conditions to approval of the petition. They did that. They did that with the requirement of changes, the modifications to the trains. They limited their speeds on the route from 110 to 79. Did they have the authority to also add the condition that they install PTC prior to service?
My interpretation of what you've just read is yes. They could have required as a special condition the installation and operation of a positive train control system.
I agree. I do want to ask a little bit about, I want to turn quickly to speed limit action plans. So speed limit action plans were to be developed for addressing areas where speed limits were reduced by 20 miles per hour. This was required in the FAST Act. Was one developed for this section of track?
There was, yes.
There was a speed limit action plan developed prior?
For the Lakewood subdivision north of Lakewood, not for the section
For
where the...
this section of track?
Correct.
There was or was not?
There was not.
There was not. And there actually was a deficiency in the law, a couple of deficiencies, where it did not apply to where railroads were operating. It only applied to their systems, and it didn't apply to new service. So there were two deficiencies and continue to be in the law. With that said, the FAST Act gave FRA authority to require additional conditions, approve with conditions. So they could have included that.
Absolutely.
Thank you.
Member Hamady, thank you very much. I do want to go back to the idea of the recommendation that we are considering closed unacceptable regarding basically moving maps or whatever that recommendation happened to be. Jeff, Mr. Marcus, let's see, that's 16-32. And it says, this is like been said, it's been, came out of the Amtrak Philadelphia accident, require railroads to install devices to develop and procedures that will help crew members identify their current location and display their upcoming routes in territories where positive train control will not be implemented. And of course, the FRA wrote back and said the word that they used was they thought that this was, they wrote us back on March the 28th of this year, saying that the need for such a system was quote unquote dubious, and the cost would quote certainly be tremendous, costing at least in the hundreds of millions of dollars, end of quote. And they also said it has little safety benefit Technology does not exist, and it, quote, has little or no known safety benefits, end of quote, to offset the significant cost. This accident here, in just property damage alone, was $25.8 million. And you add in there Amtrak 188, and you Amtrak add in Spite and Dival, and a few others where people have lost. Well, Spite and Dival, there was a sleep apnea issue there, but certainly in Amtrak 188, there was a loss of positional awareness. 10 years ago, nobody had even heard of an iPad. I hadn't. They came out in around 2010. That's when I bought my first one. Well, now, within just about 3 or 4 years of iPads coming out, every airline cockpit in the world probably has an iPad, 2 iPads in them, and they use moving map displays, 2. So so the technology is there, and Member Weiner said, well, maybe we ought to consider reiterating or something. I would certainly consider that if it were brought up. Otherwise, we will close it, closed, unacceptable, and send that letter to the FRA. But I disagree that there's no safety benefits, and I also disagree that the technology is not available. So let me move on. Let me clarify something. A little while ago, a question came up. Let me be clear about this. Once Sound Transit turned over operation, completed the project, is it true that they turned over to Amtrak everything related to the operation of that? Here's the paper I was looking for. They were Amtrak. So once Sound Transit completed the project, Amtrak was responsible for the operations of trains, including training and qualifications of crews, providing the crews, and rules compliance. Is that correct?
Yes, sir.
Yeah, so I just wanted to clarify that since I heard a question that piqued my curiosity. Now let me ask you this. Railroads operate today. Many railroads, every railroad with maybe 1 or 2 exceptions, maybe 3 exceptions, I don't know if more than 1 or 2, that are operating without positive train control. So why does staff believe that Sound Transit should have waited until PTC was installed before implementing or inaugurating the service?
That would have been the prudent decision in the best interest of passenger safety.
Okay, now was there further considerations about the preliminary hazard analysis and all that? Let's walk through that.
So the fact that an undesirable hazard, such as an overspeed derailment in curves, was allowed to be unmitigated, essentially, because we mentioned the procedural control, which has been proven ineffective. It's unbelievable to me.
Okay. Well, it happened. And so if Amtrak would have waited, or Sound Transit would have waited before PTC was ready, when would they have initiated service? In other words, when is PTC going to be fully operational? Or I think it's already ready, I think.
It's still not deployed. The best reason I can give you is the railroads continue, and this is all railroads, freight and passenger, as their deadline gets pushed further and further out, they get waivers from the FRA that say they don't have to have it deployed until December 31st of 2020. And while you were discussing, I was looking at some data that I printed out. As soon as this Congress allowed this deadline to be extended, as I said earlier, BNSF and Amtrak sent letters to the FRA asking for an exemption because they met the conditions that Congress put in the law. They sent it out in November of 2018, and FRA approved the extension by January 15, 2019 for both railroads, or for both entities. And I find it interesting that it says in here, FRA reserves the right to modify or rescind this approval upon receipt of information about the safety of rail operations or noncompliance with any applicable regulatory or statutory requirement. Are they saying that they have the right to pull the waiver and then instantly these organizations have to implement PTC? So I'm a little befuddled by the waiver exemption that they granted.
Well, thank you, Mr. DePape. I'm out of time, but I will note that Congress authorized if certain hoops were in place, that extension could be granted, and all the all the railroads applied for that and got those exemptions, I believe, all
Pretty
40,
much,
all
because
41.
they met the 6 steps in
Right.
the bill.
Right, so they were just doing what Congress enabled them to do. Vice Chairman.
I think I'm pretty well out of questions, just some comments. We seem to keep revisiting these overspeed curve conditions. This isn't the first time, or the second, or the fourth. And they seem to happen for the same reason, loss of situational awareness in most cases. That we keep granting exemptions, or I should say Congress and the FRA are complicit in this. And I don't think there's any other way to state that. They have the responsibility and the authority to make the changes. So that has to speak for itself. The other point to the FRA regarding the situational awareness, the iPads and equipment to be able to moving map displays. I would point out, Mr. Chairman, that General Aviation led the way with the air carriers. We had moving map displays and iPads in our cockpits a couple of years before you did.
Great.
Well, we like to do that, but, I think it's time for the railroad industry to move into the 21st century, and I realize they have some history on aviation, but we keep having the same conversation over again at the cost of lives and at the cost of equipment. And I'm dismayed and disgusted that this conversation continues. No further statements, Mr. Chairman.
Thank you, Vice Chairman. Member Weiner.
No further questions.
Member Hamady.
Mr. Frigo, can you clarify, do you know the operational status of PTC implementation on the Lakewood subdivision?
To my knowledge, it has still not been implemented. I do not have an implementation date.
Okay, and part of the difficulty there is when the railroads file their PTC implementation status with FRA, this particular section is under BNSF, and so the reports that are filed are just all the BNSF systems, so there's no transparency into specific sections. So that's part of the problem. One thing I want to ask you, Mr. Frigo, is the system safety plan. Why is it important?
Lays out the fundamentals for managing safety.
Okay, so in 2016, FRA issued a final rule requiring commuter and intercity passenger railroads to develop and implement this system safety program, which according to the FRA is a, quote, a structured program with proactive processes and procedures developed and implemented by commuter and intercity passenger railroads to identify and mitigate or eliminate hazards and the resulting risks on each railroad system. The regulation itself actually dates back to 2008. It was included in Section 103 of PREA, Passenger Rail Investment and Improvement Act of 2008. And that and two other portions of it, a technology implementation plan for the railroads, the future of safety technology, and a fatigue management plan was also included as part of that rulemaking. So in 2008, that rulemaking was required on risk reduction plan. How many times, let's see, 2008, it took them 8 years to publish the final rule, correct? That was 2016. So then how many times was it stayed?
6.
6 times. So we have, if we do, okay, before I do that math, once it's published, how long do the railroads have to, and right now it's intended to be published on September 4th, 2019, but that keeps getting pushed. How long do the railroads have to submit a system safety plan to FRA for review?
1 year.
1 year. How long does the FRA have to review it?
They'll have 90 days.
Okay, so then how long, after it's approved, will the railroads have to implement it?
It's a 3-year implementation.
Okay, so the math is, the mandate was in 2008, so 8 years for the final rule. 3 years now because it's been stayed 6 times, bringing us to September 4th, 2019. 1 year for submitting the plan, 90 days for reviewing the plan, and 3 years for implementing. We are now at 15 and a quarter years since it was mandated. And that's assuming that it actually gets done and mandated on September 4th, but it keeps getting pushed. Why does it keep getting pushed?
So the states are hesitant to be responsible for railroad safety. They want to be seen as sponsors, yet not take the ownership and responsibility for safety.
Hands off. It's who, the person who should be responsible are the ones who are providing the service. That is what the claim is, correct?
That's correct.
That's a problem because we saw that here where some people were hands off and shouldn't have been. So I see later that or in this report, we do recommend that FRA move forward with this quickly. And so I think that's a good addition. And I'm going to save, I do have additional questions, I'm so sorry. But so I'm going to yield back.
Perfect. That's what we're here to do, is to ask questions and probe, and so no need to apologize. I asked this question in the June 10th and 11th investigative hearing. I will ask it again. Were there operational pressures to begin service on December the 18th? Were there threats of funding being suspended or something along those lines?
It appeared that a decision was made in September to initiate service. And once that decision was made, none of the parties wanted to delay that revenue service date.
Okay, no financial reasons. I mean, no. I did read that I think the money would run out. Some sort of funding would expire. Basically the stimulus funding would have, stimulus funding would have expired. But would that have affected this?
Not to the point where it gets in the way of safety.
Yeah, but would it have put added pressures on the system? There was no financial reasons from losing funding if they had not started by the end of the year. Is that correct?
Not that I'm aware of.
Yeah, okay. I just wanted to hit that one more time. Mr. Hiller, we talk a lot about the performance or the lack thereof of the Talgo Series 6 rail cars. Can you explain how these cars compared to a conventional passenger rail car? I think you said that, and I think one thing that really struck home is that these fatalities, 3 fatalities, likely would not have occurred had this same crash occurred in a conventional car due to the construction.
In my experience, I participated in the investigation involving the Bronx derailment in 80 mile an hour into a 30 miles per hour curve. In that accident, the train set involved included all cars that were compliant with Part 238, which were the passenger safety standards. Among those elements that were included in those cars, in their design, they included truck retention strength. And we did see some of the cars uncouple and become disconnected during that derailment. But what I did not see were any rolling assemblies or bogies or truck assemblies, however you wish to refer to them, separate and become projectiles or missiles. And they did not contribute to the overall severity of the accident. So in my opinion, I believe that in this accident, had equipment that met North American or United States safety requirements been involved in this accident, we would not have seen any rolling assemblies or trucks separate and contribute to the overall severity of the injuries.
And so to be clear, a rolling assembly, and I think it was in the 8th car, I believe, where the fatalities occurred. I think I heard you say that this morning. So
Sure.
a rolling assembly detached and basically smacked into the side of the rail car, which pierced a hole in it, which caused ejections, 2 of which were fatal. And in addition to that, the rolling assembly also struck somebody inside the car, and that was a fatal injury as well. Did I characterize that properly?
In general, yes. We observed at the resting position, the rolling assembly was partially inside and outside of the car. There were some forensics that were consistent with this collision occurring prior to the bridge abutment. And yes, you are correct.
So what you're really saying is, had the rolling assembly not detached, we may not have had fatal injuries. And furthermore, something I didn't realize till I met with staff on this, I've been to several freight rail accidents where there's axles and wheels strewn all around, but I didn't realize till I met with staff that on a passenger rail car, they're not just resting there based on gravity. They are actually held in place, and that's why they don't come undone in a traditional passenger rail car.
Your observations are correct.
Thank you very much. Back at you.
We've established that PTC would have prevented this accident. So I'm going to flip it on you. What does PTC not prevent?
FRA
Wait,
made the decision.
Can I ask you a question? Maybe I can be more direct. How about a derailment due to mechanical defect? Would that? Probably not. They are not. PTC is not designed to address a derailment due to a mechanical defect. How about track defect? No.
Well, to an extent, that PTC monitors track integrity. I mean, if a rail would break and PTC system detected it, it would notify the train that there was.
But PTC wouldn't prevent all accidents on this track, correct?
No, it wouldn't.
And I'm going to stop you there. PTC would not prevent all accidents on on this section of track. Is that correct, Mr. Hiller?
That's correct.
And the reason I bring this up is not because I'm anti-PTC. I'm the most PTC person out there. And definitely, this would have absolutely prevented this accident. But the reason I bring it up is because we have a situation where there are 4 other train sets out there. And Amtrak has written a letter to FRA stating they want to restart service, and FRA has responded and said, you can reapply because submit all your documents. Now, I know that Amtrak is in the process of a procurement for replacement trains. In the meantime, we have train sets that are at about 21 years and whose useful life is between 25 and 30 years. My concern is the safety of these train sets, and we've established that they have safety deficiencies. So, Mr. Hiller, do you have concerns about do you believe these train sets should continue to be operated in service in the United States? These 4.
I certainly have concerns about these train sets and their performance.
Regardless of whether PTC.
Regardless of whether positive train control is in effect. Clearly in a high energy event, we will see articulated connection failures. We will see trains come apart, fall into their surrounding environments, and we will see rolling assemblies released. We will see that in a high energy event. I had the opportunity to travel up to DuPont in December of 2018, just after our shutdown. I witnessed a Talgo train set that had derailed in Vancouver. They had brought it back to Washington State. This derailment occurred at only 3 miles an hour on some track that would not have had positive train control. At 3 miles an hour, it left the track, and it struck a freight car, and it tore into the side of the car, essentially damaging the car at 3 miles an hour.
And that occurred,
That's a low-energy event.
when
Now
did
we're-
that occur?
That occurred in December of 2018.
Okay, great.
So I
Thank
do
you
not.
Thank you for adding that, because I was going to ask you that as well. And I just want to make sure, because I'm sure there are a lot of people viewing this. There have been a lot of changes at Amtrak and a lot of changes at FRA since all this came into play. So I believe FRA has, new people are there, they have an opportunity to do the right thing this time, and so does Amtrak, and I know that they're moving forward with a lot of additional safety measures. So I hope they take this in consideration. I do have other questions on recorders and training and compartmentalization, but I will wait until the next round.
Great, thank you very much. Still no further. Okay. To follow on to Member Hamody's question, Amtrak said they would respond to us regarding their plan for continued use of Talgo train sets. What has their response been?
To date, none.
None. Thank you. Mr. Hiller, while I've got you, I want to ask you a question that continually comes up after train crashes where there are ejections. People ask the question about seatbelts. And we have come out with a recommendation regarding that coming out of the Amtrak Philadelphia accident, Amtrak 188, recommendation R16-35. And basically, Mr. Marcus, do you have that rec handy? I can get it.
I do.
All right, would you read it for me, please?
The recommendation is conduct research to evaluate the causes of passenger injuries in passenger car derailments and overturns and evaluate potential methods for mitigating those injuries, such as installing seatbelts in rail cars and securing potential projectiles.
Yeah, so what's the status of that recommendation?
We have the initial response from the FRA in August of 2017. They, in essence, said pretty firmly that they would not put in seatbelts. If you don't mind, I will read a paragraph from their letter that I think summarizes what they feel that. They say the current research indicates that unlike in the automobile and air transportation modes, adding seatbelts in passenger rail cars is not the most effective means to increase safety. The purpose of passenger protection devices such as seatbelts is to allow occupants to survive the deceleration of the volume. During a collision, deceleration of the volume varies significantly based on transportation mode. Passenger rail coaches experience a peak deceleration of 1/4 that of an automobile during a collision. As such, the interior of a typical passenger rail car can provide a level of protection without active restraints, at least as effective in preventing fatalities as the protection provided in automobiles and airplanes.
Yeah, thanks. So the FRA came back with an answer that basically said it's different than riding in a car. That's good to know, but how does that, Mr. Hiller, how about passenger ejections? What they just addressed says nothing about ejections. At least 2 of the fatalities and several of the serious injuries in this particular accident were ejection related, I believe. And we talked about it this morning when we were over at Capitol Hill, and I think in Amtrak 188, there were 4 fatalities due to ejections. So what does, seatbelts, do they work? Do they keep people from being ejected? We've certainly said that with motor coaches. We certainly have said that with respect to automobiles. I don't get it. When I ride on a train, I feel very uncomfortable sitting down in a seat knowing that that vehicle is going to be moving much faster than I would more than likely drive. Please.
Chairman, in the last several years, we've seen several accidents where rail cars have ended up on their sides or on their roofs. And of course, through our investigation, we made recommendations to explore the use of enhanced occupant restraint systems such as seat belts. And of course, we hear that the FRA believes that this is, again, not in the interest of railroad safety. They cite that they've got issues related to, comparability, lower accelerations, and their choice for occupant protection historically has been to minimize the amount of distance you travel from, seat to seat in a compartmentalized manner. Takes no bearing into a rollover or an overturn. So staff had considered this when we've proposed the recommendation that we would like them to explore in a more comprehensive way mitigation strategies for occupant protection. So we're asking them again to basically explore the types of retention systems or mitigating factors or occupant protection strategies that are best suited for rail passenger safety.
Thank you very much. Member Hamady.
I want to continue on with that. I actually rode the Talgo Series 8 train from Portland to Eugene, I believe, in November of 2017 with a former colleague. And it is a very spacious, comfortable seating arrangement. And one question that brings up compartmentalization. So how is it different? Can you talk about compartmentalization and talk about how it's different in the Talgo 6 train?
No? Okay. So the strategies used in compartmentalization typically include higher seat backs and angularity of the seat backs themselves to sort of control the distance somebody would travel in a collision. And this would be in sort of a longitudinal manner. In the Talgo Series 6, this spacing is much greater than those now understood to be more protective. And in addition, the seat backs themselves are not very high, so you don't have sort of that additional protection with the higher seat backs that would prevent head and neck injuries as well.
Volpe did an evaluation in 2001 which stated that more injuries were predicted in a Talgo 6 train than in a conventional train. The quote was, secondary impact velocities between the occupants and seats or other interior surfaces are predicted to be greater for the Talgo 6 train than for conventional trains. A higher number of injuries are predicted to occur on Talgo 6 train than on the conventional train for unrestrained forward seating occupants. I'm assuming you saw that. Our report states that the current research doesn't address the effectiveness of compartmentalization for those individuals that are outside the standard range. Can you describe the testing and why this additional research is important?
Yes, ma'am. The current research and testing involves using anthropomorphic dummies that are in the 50 percentile male, which is an individual of 171 pounds, and a 95th percentile male, which is 223 pounds. There is no testing on either side of those weight ranges regarding compartmentalization.
And can you talk a little bit about our recommendation or our discussion of the need to address child safety seating?
Yes, ma'am. So today, the public expects to be able to, in whatever mode of transportation they pick, to have available to them a safe way of transporting their children. There was certainly an expectation by the parents of the child that was in this train that they were going to be able to secure the child seat they brought with them. And child safety seats is a common device that's used to secure a small child.
And we're not recommending that Amtrak provide child safety seats, but what we're recommending is similar to cars and planes where there are seat belts that could secure a car seat, and then telling them how to use that, their customers.
We
or
are
how they could
recommending
safely.
the seats that have the anchor points to allow a child seat to be secured to it, and the belts that would allow that to occur.
Great. Thank you very much. I think quickly with my 46 seconds, I'm going to ask, the Charger locomotive was equipped with inward-facing cameras that captured visual and audio recordings of crew member activities on the day of the accident. Dr. Jenner, how did this help investigators determine what happened?
These are very valuable tools for the investigation. And we've identified literally dozens of investigations in the past that would have benefited from inward-facing video and audio. It gives us a window to a first-hand of what's going on in the operating compartment. We rely, without them, we rely on interviews and the recollections, which as much as they try to get it accurate is not always the case. And if someone's injured, there will be a delay of several weeks or months, and that may affect the accuracy of their memories. In the interview, the engineer did mention the overspeed alarm, and it sounded like he addressed it without incident. When we had the opportunity to view what exactly happened and the timing of it and his response to it, it sort of opened up a window to a safety issue that we may not have recognized without the use of the video and audio.
Thank you. I'll keep going. Okay.
I want to talk more about the audio part if you want to.
And I think that's crucial, the opportunity to review exactly what happened. So when I initially read the report, the draft report, I kind of keyed off this. There were a couple of phrases about how, the engineer and the conductor or qualifying conductor had had a very brief conversation before the overspeed derailment. So I wondered, was distraction an issue here? But we found that wasn't. Can you briefly address that?
As I described, the critical failures occurred between milepost 18 and 19. There were 3 or 4 signs that were important for him to detect and respond to. During that time, however, there was no conversation between the engineer and the conductor, so we can eliminate distraction from conversation from our analysis.
Thank you. And actually, so I saw the video recording and heard the audio, and when I viewed it, it was very clear that wasn't an issue. What was very clear is there was a lot of confusion, and which brought me back to the training issue. So I want to go back to recorders and talk. Can you provide an example in the past where not having the audio capability has maybe hindered an investigation? Maybe New Mexico, I think there was something there with.
I think that Roswell, New Mexico case would be a good example of that, where there were issues surrounding the crew that we were unable to fully delve into because of the lack of audio and video capabilities in that locomotive. Certainly there are others Amtrak 188, the overspeed derailment did not have inward-facing audio and video and delayed some of our ability to respond to address distraction in the cab with that in terms of mobile phone usage that we were ultimately able to rule out. In this case, we were able to rule it out immediately because we had the audio and video of what was happening in the cab.
Okay, and I do have a couple more things on that, but I'll come back to it, and
That'd be great.
thank you.
Okay, yeah, thanks. I did want you to complete that train of thought about the importance of audio, and I know we have recommendations, and you have an amendment in that area too, so proposed amendment. Member Hamady touched on the child seats, and Ms. Harley, those of us who've read the report know how close this came to losing an infant in this accident. Could you please describe what had happened?
Yes, sir. Approximately 1 minute before the derailment, the father had actually removed the child and walked into the lavatory. And then the derailment occurred after they had gotten into the lavatory.
And what happened to that child seat or bassinet or whatever it happened to have been?
The child car seat essentially became a missile and was actually thrown out of the derailed train car.
Think about that next time you have to change a diaper, that it may not be the worst thing in the world. Mr. Hiller, you wanted to say something.
Chairman, in anticipation of this discussion, staff has provided one of the photographs of the child seats, and if you would like, we can put it up on the
Yeah, I
monitor
think that's
for you.
worthwhile, inside, yeah. Yeah, let's do it. So right there in the blue, or Ms. Harley, you go ahead, please.
Yes, sir. The child seat is in the blue and it's tagged. The child seat is actually sitting next to train car 7424, and the car in which it came out of is actually on top of the car you're looking at.
So that underscores the importance of what you were speaking about earlier, about the importance of having these anchor points for a child seat. Thank
Yes,
you.
sir.
Mr. Hiller, Member Hamady asked your opinion about whether or not these Talgo train sets should be removed, but in the report, just to put, the NTSB will hopefully adopt a report earlier or later today that will say the FRA should have serious concerns about the continued use of this train set. And that's a pretty strong statement. I just want to ask one more question. And I'd like for Mr. Frigo, it's important for me to have you outline the things that Sound Transit was supposed to have done but did not do.
So the final safety certification and verification process should have incorporated testing that would validate hazard mitigations. That testing would have undoubtedly found the missing crew focus zone. It would have validated a human's ability to operate on the territory. And I truly believe it would have turned the focus back to that initial PHA, which highlighted the necessary mitigation of positive train control.
Thank you very much. I have no further questions. And before we turn to Member Hamady, do either of my other two colleagues have anything? Member Hamady.
I think I'm going to leave it on that note. I just want to say thank you. You all did a fantastic job on this investigation and with this report.
Well, I
Thank
think we could all unanimously agree on that, and we'll have the opportunity to, hopefully, here in a few minutes. Why don't we take a 10-minute break? I tell you what, let's be back, according to that clock up there, at, let's be back at 4:15. And before we do, Mr. Sledzik, if you would kindly tell us the significance of these page changes that were left on our desk.
Certainly, sir. So there are 5 pages that were left with you when you arrived at the dais. 3 of them were sent to you on May 17th as well in a memo. So these are page changes. I'll read the pages that you have. 219A shows a change to finding number 28, and these are small editorial changes. Change to finding 28. Page 220A, findings 33 and 36 have a slight modification. I'll pause while you check those. All right, and then the remainder are 231, 232, and 233, all A, and those are changes to recommendation number 23, and then the 232A and 233A are the reiterated and reclassified recommendations.
Which those pages, 231, 230, those last three pages have already been distributed through the notation process on the 17th, and I see the date at the top. So the only two that we should not have are the first two, which are dated 5/2019. That's 219A and 220A. Is that correct?
That is correct. So it's findings 28, 33, and 36 have the slight editorial changes.
Great. Before we break, any questions on that? So we're really just amending 2 pages above and beyond what we've already received page changes on.
Correct. That's correct, sir.
Okay, good. All right, we can work that out. We'll see you at 4:15. We are in recess. Okay, we're going to start in 1 minute.
This is the actual script with your findings and your recs and stuff in here, like we did last time.
Okay.
Mr. Vice Chairman, please.
Thank you very much.
Used to say that government could mess up.
So that's like we did
Well,
last
may
time.
I add a waterfall to that?
Oh, okay. Okay, guys, we're about ready. Everybody ready? Okay, we're back in session, and do any of my colleagues have any further questions for staff? Seeing none, Mr. Sledzik, if you would please read the proposed findings.
Yes, sir. As a result of this investigation, staff proposes 53 findings in 6 issue areas, and we've covered these, but I'll reiterate them for the audience. First one would be image and audio recording devices. Second one is positive train control. Third, human performance. Fourth, preparation for the inaugural Cascade service. 5, crashworthiness. And lastly, survival factors. First, we typically do an exclusionary finding, and I'll read that. This is finding number 1. None of the following was a factor in this accident: the mechanical readiness of the train, the condition of the tracker signal system, the weather, cell phone use, medical conditions of the Amtrak engineer, use of alcohol or other drugs, fatigue, or any impairment or distraction. The next 3 findings focus on image and audio recording devices. Finding number 2, this accident has demonstrated the value of image and audio data for the accident investigation and development of safety recommendations. Finding 3, the Federal Railroad Administration has demonstrated an unwillingness to implement the recommendations and regulation that would require inward-facing video and audio devices that are critical to accident investigations and improving safety on our nation's railroad. And finding number 4, inward-facing recorders with both image and audio capabilities can increase the understanding of the circumstances of an accident and ultimately provide greater precision and safety recommendations and subsequent safety improvements. The next finding relates to positive train control. This is finding number 5. Had the positive train control system been fully installed and deployed at the time of the accident, it would have intervened to slow the accident train to the proper speed, and the overspeed derailment would not have occurred. The next 7 findings focus on human performance, including training and the use of warning plaques. Finding number 6, the Amtrak qualification program for the Point Defiance bypass did not effectively train and test qualifying crew members on the physical characteristics of a new territory. Finding 7, Amtrak did not provide sufficient training on all characteristics of the Charger locomotive. Finding 8, the engineer's unfamiliarity with and fixation on the audible and visual alerts associated with the overspeed alarm reduced his vigilance of events outside the locomotive moments before the accident. Finding 9, engineers could better master the characteristics of a new locomotive with the use of simulators. Finding 10, a systematic approach to training would have aided Amtrak managers in recognizing the challenges of operating new equipment on new territories. Finding 11, supplemental warning plaques, such as distance ahead plaques and other types of conspicuous signs, strategically positioned after an advanced warning speed reduction sign would provide enhanced visibility as an added level of safety for operating crews of passenger and freight trains. And finally, finding 12, crew members qualifying on a territory can and should play an active role in establishing and maintaining safe train operations. Now, the next 17 findings relate to the coordination between agencies and operators for the inaugural Cascade service on the Point Defiance bypass and the associated safety planning and oversight. Finding 13, had the Washington State Department of Transportation, Central Puget Sound Regional Transit Authority, Amtrak, and the Federal Railroad Administration been more engaged and assertive during the preparation of the inaugural service, it would have been more likely that safety hazards, such as the speed reduction for the curve, would have been better identified and addressed. Finding 14, the Federal Railroad Administration did not include planned and under construction alignments and did not require periodic updates to intercity and passenger railroad speed limit action plans, which led to no speed limit action plan being developed. Finding 15, the Federal Railroad Administration should have ensured that speed limit action plans include new or updated routes owned or operated by railroads, even though it is not required by the Fixing America's Surface Transportation Act. Finding 16, Central Puget Sound Regional Transit Authority did not update the timetable on its Lakewood subdivision to identify the curve at milepost 19.8 as a crew focus zone, which would have helped to mitigate the overspeed derailment risk. Finding 17, Amtrak failed to update the operating documents prior to starting revenue service, which would have highlighted the speed reduction at the accident curve. Finding 18, Central Puget Sound Regional Transit Authority's omission of the final activities of the certification process resulted in the failure to control the identified hazardous condition of an overspeed derailment at the accident curve. Finding 19, Central Puget Sound Regional Transit Authority failed to implement effective mitigations in lieu of positive train control to control the hazard at the accident curve. Finding 20, there was no requirement for the Washington State Department of Transportation, Central Puget Sound Regional Transit Authority, or Amtrak to provide additional protection for the accident curve. Finding 21, because the Federal Railroad Administration did not act on the recommendation to add technology to assist engineers in determining their location, an opportunity to improve safety was overlooked. Finding 22, Washington State Department of Transportation should have provided greater oversight of the Central Puget Sound Regional Transit Authority's safety certification process. Finding 23, the Federal Railroad Administration's current requirement to review but not to approve system safety program plans does not achieve the level of safety oversight expected from the Federal Railroad Administration. Finding 24, without positive train control and the lack of oversight to implement mitigations, there was an increased safety risk to the traveling public. 25, Amtrak did not take an active enough role in reviewing safety aspects during the preparation of the Point Defiance bypass to ensure a safe operation. Finding 26, Amtrak failed to assess, evaluate, and act upon readily identifiable safety hazards to ensure the safety of the Point Defiance bypass for the traveling public and its own train crews. Finding 27, Amtrak needs to implement a safety management system on all of its operations, whether internal or on a host railroad. Finding 28, the repeated postponement of Title 49 Code of Federal Regulations Part 270, entitled System Safety Program, has delayed needed safety improvements for the passenger rail industry, rail employees, and the traveling public. And lastly, finding 29 in this section, the use of risk assessments to identify, mitigate, and control risk on the new and upgraded service will increase the level of safety to Amtrak operations over all territories. The next 9 findings focus on the crash worthiness of the Talgo rail cars. The Talgo Series 6 passenger rail car AMTK 7424 did not provide adequate occupant protection after its articulated connections separated, resulting in complex, uncontrolled movements and secondary collisions with the surrounding environment, which led to damage so severe to the rail car body structure that it caused passenger ejections. Finding 31, the failure of the articulated connections of both Talgo Series 6 passenger rail cars AMTK 7422 and AMTK 7504, the detached rolling assembly from AMTK 7422 and its secondary collision with AMTK 7504 directly resulted in 3 fatalities and 2 partially ejected passengers who had been traveling in AMTK 7504. The safety straps, finding 32. The safety straps used for the Talgo Series 6 train set rolling assembly retention modifications were degraded due to their use in exposed outdoor conditions and were used far past their service life. Finding 33. During the grandfathering approval process, the Federal Railroad Administration failed to consider the limited useful service life of the nylon straps used for the Talgo Series 6 train set rolling assembly retention modifications, which had degraded and failed to improve the crashworthiness of the train. Finding 34, the Talgo Series 6 train set is structurally vulnerable if it is involved in a high energy derailment or collision due to its lack of crashworthiness protections and is at risk to severe and catastrophic loss of survivable space. Finding 35, the Talgo Series 6 train set, designated as Amtrak Train 501, was not in compliance with the terms and conditions of the Federal Railroad Administration's grandfathering agreement. Finding 36, allowing the grandfathering provision to remain in Title 49 Code of Federal Regulations 238.203, subsection D, entitled Grandfathering of Non-Compliant Equipment for Use on a Specified Rail Line or Lines, is an unnecessary risk that is not in the public interest nor inconsistent with railroad safety. Finding 37, the Talgo Series 6 train set does not meet current United States safety standards and possesses unnecessary risk to railroad passenger safety when involved in a derailment or collision. And lastly, 38 in this section, finding 38, the lead locomotive's crashworthiness design and crash energy management features minimize the severity for injuries and fatalities to the train crew by performing as intended in this accident. Now, the last set of 15 findings relate to survival factors areas including emergency lighting, signage, compartmentalization, seat design, passenger ejections, and emergency response. Finding 39, after the Talgo train set separated from the power cars, there was no power to the train for emergency lighting, which hampered the ability of passengers to evacuate the train and the ability of first responders to conduct rescue operations within the rail car. Finding 40, the lack of emergency lighting hampered the ability of passengers to evacuate the train and the ability of the first responders to conduct rescue operations within the rail car. Finding 41, the instructional signs located above the rail car door exit controls and manual release mechanisms lack the required high-performance photoluminescent material or a suitable alternative that would have allowed them to be visible and read in low light or no light environments. Finding 42, the inability of passengers to see and read the instructional signs regarding the exit controls and the manual release mechanisms resulted in the inability of the passengers to use that point of egress for escape and delayed their evacuation from the train. Finding 43, the rotation of the train sets, 1, minimized the effectiveness of compartmentalization by allowing passengers to travel greater distances within the rail car during the accident, 2, caused injuries to several passengers, and 3, decreased the available aisleway space for passenger egress. Finding 44, existing procedures and design standards for anti-rotational seat locking mechanisms do not adequately protect passengers in accidents. Finding 45, the failure of the articulated connections defeated the compartmentalization feature of AMTK 7421 and provided a pathway for passenger ejection. Finding 46, when the articulated connections failed, it resulted in a secondary collision that caused rail car AMTK 7424 to roll over onto its roof and collapse its structure, which dislodged the windows and allowed passengers to be ejected. Finding 47, limited research has been conducted into the effectiveness of compartmentalization in passenger rail cars for individuals that fall outside the testing standard range, such as small children. Finding 48, the inability to secure child safety seats in a passenger train results in an undue risk to children due to uncontrolled or unexpected movements during a derailment or collision. Finding 49, Amtrak should develop a policy for safely accommodating parents traveling with small children restrained in child safety seats. Finding 50, this accident shows the need for the Federal Railroad Administration to take the action on safety recommendations R1635 and R1636, which addressed the Federal Railroad Administration's occupant protection standards. Finding 51, since there was no common incident command radio channel between fire and rescue agencies, law enforcement and emergency management and emergency response lacked efficient coordination. Finding 52, the lack of interoperability of the emergency communication system used by Joint Base Lewis-McChord resulted in poor communications that adversely affected the coordinated rescue effort. And lastly, finding 53, incompatible radio frequencies or similar communication issues may exist at other locations where military and civilian agencies coordinate their emergency response.
Mr. Sledzik, thank you very much for reading those, and I want to thank you also for chunking them into groups like you did, which I think was an enhancement. I know we have several amendments, but before we get into possible amendments, do any of my colleagues have any questions concerning any of the proposed findings? I have two questions myself. The first question is on regarding finding number 27. We say Amtrak needs to implement a safety management system on all of its operations where internal whether internal or on a host railroad. My question there is I was under the impression that Amtrak had a fairly robust SMS.
Amtrak, following the recommendations that the board made in Chester with the Chester accident, Amtrak initiated a rollout of its safety management system. However, when Amtrak is off of its own property and it's on a host railroad, the same level of risk analysis, risk assessment, hazard management is not there.
Well, I was under the impression that they were actually doing that, and maybe I'm wrong, but they were actually going out and doing a mile-by-mile risk assessment of territory in which they are the tenants. Is that not true?
That's all recent activity, and it's not 100% complete.
Okay. Well, I want to acknowledge the good work that they are doing. And as Member Hamady pointed out, right after this accident, they had a new CEO take over and brought in a new chief safety officer, senior vice president, executive vice president, and they are probably a different railroad than they were at the time of this tragedy. And I think we need to acknowledge that and show appreciation for the work that they are doing. My next question is on finding number 35. And it says the Talgo Series 6 train set designated as Amtrak Train 501 was not in compliance with the terms and conditions of the Federal Railroad Administration's grandfathering agreement. Mr. Hiller, how were they not in compliance with that?
The terms associated with a grandfathering agreement should be considered as a whole. And in that, if one of the conditions required to meet the terms and conditions of the grandfathering agreement were not met, then the agreement is not met. So the degraded conditions of the straps were such that they were no longer compliant with what was agreed to. They would put on a safety cable that would essentially meet a certain design capacity, and when we tested them, they did not. and thereby they were not in compliance with the grandfathering agreement.
Okay, I appreciate that clarification.
You're welcome.
I just want to make sure. I know that we have several amendments, so I have one amendment to a finding, and I believe Member Hamady has several, or any other amendments to the proposed findings. Then why don't we just take them in the order in which they are? I'd like to offer an amendment. I'd like to offer a motion to amend finding 5 to read as follows, and I want to point out that this is exactly the same as was emailed out to everyone yesterday, so there's no changes to that, and I believe that the amendments that Member Hamady is proposing today were exactly the same that were emailed out yesterday afternoon. So my motion is that finding 5 be modified to state, had the positive train control system been fully installed and operational at the time of the accident, comma, it would have intervened to stop the train prior to the curve, comma, thus preventing the accident. That is my motion. Is there a second? Thank you. It's been moved and seconded by the Vice Chairman. Is there any discussion? And I will begin to explain my motion, is that basically PTC in this sort of a system, the IETMS system that would be installed, interoperable, whatever ETMS stands for, basically PTC. It doesn't it doesn't slow the train to the desired speed. The way it's currently written is it would slow the train to the proper speed, but it doesn't do that. It actually applies a full service brake application, stops the train, the system has to reset, and then it can continue. So the way that it is written as is, it is not technically correct. So that's the reason for my motion.
I support, I think it's a good motion.
Thank you. I'd like for staff to be able to weigh in on that.
Staff supports.
Thank you. Any comments from my colleagues? With that, all in favor of adopting the motion as amended? Excuse me, it's getting late. All in favor of adopting, whatever I'm supposed to say. All in favor of approving the motion as moved and seconded, please signal with a hand and say aye. Opposed, there are none. The amendment, finding 5 has been amended. Member Hamady, and it was a unanimous vote. Member Hamady, I turn to you.
I have an amendment to, or I offer a motion to amend finding number 14. So it will now read, the Federal Railroad Administration did not use its authority provided under the Fixing America's Surface Transportation Act to approve speed limit action plans with conditions, to require inclusion of planned and under construction alignments owned or operated by railroads, and to require periodic updates to railroad speed limit action plans, which led to no speed limit action plan being developed.
Okay, it's been moved. That's the motion. Is there a second?
Second.
It's been seconded by the Vice Chairman. Discussion.
Just to explain on the FAST Act itself had some areas where it did not include new future alignments, but the FRA has authority under Section 11406C of the FAST Act to approve with conditions. So they could have approved, and I want to make very clear that they had that authority.
Thank you. Comments, questions from my colleagues? Staff.
Staff supports.
Okay, any further discussion? All in favor of adopting finding number 14 as proposed, please signal with a hand and say aye. Opposed, there are none. The motion to amend finding 14 has passed. Member Hamady.
I offer a motion to amend finding number 15, so it now reads, the Federal Railroad Administration should have ensured that speed limit action plans include new or updated routes owned or operated by railroads using its authority in the Fixing America's Surface Transportation Act.
Okay, it's been moved. Is there a second? Member Weiner has seconded. Any discussion? I recognize
Same
Member Hamady.
reasons as before.
Same as before. Any discussion? Staff?
No discussion from staff. We support.
Okay, it's been moved and seconded to adopt finding number 15 as proposed. All in favor, please signal with a hand and say aye. I was wondering if you will raise your hand on your own motion there. Opposed, opposed, say nay and raise your hand. There are none. Finding number 15 has been amended unanimously. Member Hamady.
And that's a sign of needing more caffeine, by the way, when you don't raise your hand right away. I offer a motion to amend finding number 27. So it will now read, Amtrak needs to implement a safety management system on all of its operations, whether internal, on a host railroad, or in states that own infrastructure over which Amtrak operates.
There's the motion. Is there a second?
I'll second.
Been seconded by the Vice Chairman. Discussion.
To explain, the original finding only addressed internal and host railroads, and while Amtrak has a number of agreements with host railroads, there are 4 states in which Amtrak operates, and those states own infrastructure. The New York Metropolitan Transportation Authority and Connecticut Department of Transportation own 56 miles owned and operated by Metro North between New Rochelle, New York, and New Haven, Connecticut. The state of Massachusetts owns 38 miles between the Massachusetts-Rhode Island border and Boston, and Amtrak also operates, maintains, and dispatches a 135-mile right-of-way in Michigan. So my amendment would clarify that they also need to implement a safety management system for those areas as well.
Okay, thank you very much. Comments, discussion from my colleagues, staff?
The staff appreciates the clarification and supports.
Okay, it's been moved and seconded to adopt amend finding 27 as presented. All in favor, please signal with a hand and say aye. Opposed, there are no nays. The motion carries unanimously. So we've just adopted 4 new findings. Now we need to go back and adopt the findings as amended. Do I have a motion to adopt all of the findings as we just amended?
So moved.
Second.
Okay, Member Weiner has moved, seconded by Member Hamady. Is there any discussion? Seeing none, all in favor of adopting the findings as amended, please signal with a hand and say aye. Opposed? There are none. The findings have been adopted unanimously. Now, Mr. Sledzik, if you'll kindly read the proposed probable cause.
Yes, sir. Staff proposes the following probable cause. The National Transportation Safety Board determines the probable cause of the derailment was Central Puget Sound Regional Transit Authority's failure to provide an effective mitigation for the hazardous curve without positive train control in place, which allowed the engineer to enter the 30-mile-per-hour curve at too high of a speed due to his inadequate training on the territory and inadequate training on the newer equipment. Contributing to the accident was the Washington State Department of Transportation's decision to start revenue service without being assured that safety certification and verification had been completed to the level determined in the preliminary hazard assessment. Contributing to the severity of the accident was the Federal Railroad Administration's decision to permit rail cars that did not meet regulatory strength requirements to be used in revenue passenger service, resulting in 1, the loss of survivable space, and 2, the failed articulated railcar-to-railcar connections that enabled secondary collisions with the surrounding environment, causing severe damage to railcar body structures, which then failed to provide occupant protection, resulting in passenger ejections, injuries, and fatalities.
Thank you for reading that, and I have an amendment. Do any others, any of my colleagues have any proposed amendments to the probable cause? So my motion is that we insert the word Amtrak, and I'll read the part that's changed, that we are going to add the word Amtrak both to the train number and the Amtrak engineer. So my motion is as follows. And I will read the part that's changed, if that's okay. And Ms. Hillbaugh, you would go along with that. Chairman's motion is probable cause be amended to state the following. The National Transportation Safety Board determines that the probable cause of the Amtrak 501 derailment was the Central Puget Sound Regional Transit Authority's failure to provide an effective mitigation for the hazardous curve without positive train control in place, which allowed the Amtrak engineer to enter the 30-mile-an-hour curve at too high of a speed due to his inadequate training on the territory and inadequate training on the newer equipment. Period. The rest is exactly as presented. To be very clear, I'm just adding the first sentence as you have here in the blue line strikeout, Amtrak 501, and then the Amtrak, add Amtrak to specify the engineer. So that is my motion. Is there a second?
Second.
I think I got second, thirds, and fourths on that one. So Member Hamady seconded that one. So is there any discussion? Seeing none, staff?
No discussion from staff. We support, Chairman.
Thank you. All in favor of adopting the probable cause as amended, please signal with a hand and say aye. Aye. Opposed? There are none. So the probable cause has been adopted as amended. Nothing else to do on that. Is that right? Okay. Thank you. Now, Mr. Sledzik, if you'll kindly read the proposed recommendations.
Yes, sir. As a result of this investigation, staff proposes 26 new safety recommendations, the reiteration of 3 recommendations, and the reclassification of 3 recommendations. First, I'll read the new recommendations. There's one recommendation to the Secretary of Transportation. Number 1, require the Federal Railroad Administration to comply with Fixing America's Surface Transportation Act and issue regulations for inward-facing recorder regulations that include audio recordings as recommended by the National Transportation Safety Board in R-10-01 and R-10-02. There are 8 recommendations to the Federal Railroad Administration. Recommendation number 2, study the efficacy of how signs used in other modes of transportation may be effectively used in the railroad industry. Recommendation 3, require railroads to periodically review and update their speed limit action plans to reflect any operational or territorial operating changes requiring additional safety mitigations and to continually monitor the effectiveness of their speed limit action plan mitigations. Recommendation 4, require railroads to apply their existing speed limit action plan criteria for overspeed risk mitigation to all current and future projects in the planning, design, and construction phases, including projects where operations are provided under contract. Recommendation 5, prohibit the operation of passenger trains unless positive train control is implemented or an equivalent redundant safety system is active on the new, refurbished, or updated territory. Recommendation 6, remove the grandfathering provision within Title 49 Code of Federal Regulations, Part 338.206, subsection D, and require all rail cars comply with the applicable current safety standards. Recommendation 7, use your authority and compel all commuter and passenger railroads to meet the requirements outlined in Title 49 Code of Federal Regulations, Part 238 without delay, such that in the event of a loss of power, adequate emergency lighting is available to allow passengers, crew members, and first responders to see and orient themselves, identify obstacles, safely move throughout the rail car, and evacuate safely. Recommendation 8, reevaluate existing seat securement mechanisms and their susceptibility to inadvertent rotation to identify a means to prevent the failure of these devices to maintain seat securement. Recommendation 9, conduct research into the effectiveness of occupant protection through compartmentalization for passengers whose size, including children, is not within the current range of anthropomorphic passenger sizes in Federal Railroad Administration standards. There's one recommendation to the United States Department of Defense Fire and Emergency Services Working Group. Recommendation 10, identify all military installations that provide emergency services to areas outside of their installations, make them aware of this accident, and determine the effectiveness of the communication system between that military installation and the adjacent jurisdictions. And then a subpart of that, number 2, implement a plan to address any deficiencies with interoperability caused by the incompatibility between the U.S. Department of Defense communication system and that of adjacent civilian agencies. There are 2 recommendations to the Washington State Department of Transportation. Recommendation 11, discontinue the use of Talgo Series 6 train sets as soon as possible and replace them with passenger railroad equipment that meet all current United States safety requirements. To the Washington State Department of Transportation, Amtrak, hang on one second. Yeah, the Oregon Department of Transportation, sorry, my pages were a bit underside there. 12, develop and implement a program by which all rail car seats that are designed to rotate be checked for the proper positioning and securement in place before the rail car can be placed into or returned to passenger carrying service. There are 11 recommendations to Amtrak. Recommendation 13, ensure operating crew members demonstrate their proficiency on the physical characteristics of a territory by using all resources available to them, including in-cab instruments, signage, signals, and landmarks, under daylight and nighttime conditions, and during observation rides, throttle time, and written examinations. Recommendation 14, revise your classroom and road training program to ensure that operating crews fully understand all locomotive operating characteristics, alarms, and the appropriate response to abnormal conditions. Recommendation 15, require that all engineers undergo simulator training before operating new or unfamiliar equipment, at a minimum, experience and respond properly to all alarms, and when possible, undergo simulator training before operating in a revenue service in a new territory and experience normal and abnormal conditions on that territory. Recommendation 16, implement a formal, systematic approach to developing training and qualification programs to identify the most effective strategies for preparing crew members to safely operate new equipment on new territories. Recommendation 17, work with host railroads to conduct a comprehensive assessment of the territories to ensure that necessary wayside signs and plaques are identified, highly conspicuous, and strategically located to provide operating crews the information needed to safely operate their trains. Recommendation 18, conduct training that specifies and reinforces how each crew member, including those who have not received their certifications or qualifications, may be used as a resource to assist in establishing and maintaining safe train operations. Recommendation 19, update your safety review process to ensure that all operating documents are up to date and accurate before initiating new or revised revenue operations. Recommendation 20, incorporate all pre-revenue service planning, construction, and route verification work into the scope of your corporate-wide system safety plan, including your rules and policies, risk assessment analyses, safety assurances, and safety promotions. Recommendation 21, work collaboratively with all host railroads in an effort to develop a comprehensive safety management system program that meets or exceeds the pending Federal Railroad Administration Regulation Title 49 Code of Federal Regulations Part 270, titled System Safety Program. Recommendation 22, conduct risk assessments on all new or upgraded services that occur on Amtrak-owned territory or host railroads. Recommendation 23, develop policies for the safe use of child safety seats to prevent uncontrolled or unexpected movements in passenger trains and provide customers with guidance for using these child safety seats. And lastly, there are 3 recommendations to the Central Puget Sound Regional Transit Authority. Recommendation 24, immediately conduct a review of all operating documents and ensure that safety mitigations are applied with uniformity throughout the entirety of your territory. Recommendation 25, in areas of your territory where you are a host of a tenant railroad, coordinate with all current and any prospective tenants on the development of operating documents, including timetables, general orders, and special instructions. And lastly, 26, review your internal process for safety certification and verification, perform a gap analysis, and develop an action plan to address the deficiencies identified in the gap analysis and detailed in this report to enhance the verification activities on the projects. So that concludes the new recommendations. There are 3 reiterated recommendations that staff proposes in this report, and they were all made to the Federal Railroad Administration. So recommendation R 1717 is enact Title 49 Code of Federal Regulations, Part 270, System Safety Program without further delay. Next is recommendation R-16-35, conduct research to evaluate the causes of passenger injuries and passenger rail car derailments and overturns and evaluate potential methods for mitigating those injuries, such as installing seatbelts in rail cars and securing potential projectiles. And lastly, recommendation R-16-35, when the research specified in safety recommendation R-16-34, I think, 30, so this is recommendation R-1636. When the research specified in safety recommendation R-1635 identifies safety improvements, use the findings to develop occupant protection standards for passenger rail cars that will mitigate passenger injuries likely to occur during derailments and overturns. And lastly, staff has proposed 3 previously issued recommendations to be reclassified in this report, and all of these were also issued to the Federal Railroad Administration. Recommendation R-16-32, which reads, require railroads to install devices and develop procedures that will help crew members identify their current location and display their upcoming route in territories where positive train control will not be implemented. And staff proposes that this recommendation be classified as closed, unacceptable action. Next is recommendation R-16-35, which reads, conduct research to evaluate the causes of passenger injuries in passenger rail car derailments and overturns and evaluate potential methods for mitigating those injuries, such as installing seatbelts in rail cars and securing potential projectiles. This recommendation will be classified as open, unacceptable response, as staff recommends. And lastly, recommendation R-16-36, which reads, when the research specified in safety recommendation R-16-35 identifies safety improvements, use the findings to develop occupant protection standards for passenger rail cars that will mitigate passenger injuries likely to occur during derailments and overturns. And this recommendation, we suggest, will be classified as open, unacceptable response. And that ends the recommendations.
Thank you very much. I believe we have, I have some amendments at the desk. Member Hamady has submitted some. And do you have an amendment as well?
I do, sir.
Okay, I'm just finding out. Any other amendments? Okay, why don't we just take them in order? Member Hamady, I recognize you. I think you have something beginning with safety recommendation number 1.
I do, and I do, at the appropriate time, I do have a question to clarify a difference in wording in one from earlier in the report. So
Yeah,
just let me know
please.
when that is.
Yeah, let's go ahead and do that now. Thank you.
Okay,
Thanks for doing
I
that.
just want to clarify on recommendation 22-3, I think. I don't know, my paging is.
What page?
I think it's 231. On the top, develop policies for the safe use of child safety seats. At the end there, instead of using this child safety seats, I think it's supposed to say securing, correct? Because it does earlier in the report. I just want to make sure that that change will occur at some point. My concern is I don't want Amtrak to feel like they have to tell someone how to use a child safety seat. It's the securing portion. So that was a comment I made earlier and in the draft, and I just want to make sure that's carried over from earlier in the report.
Okay, let me ask you this, just for clarification. Is it written properly in the main body of the report?
It is.
It is. So what page is it on the main body of the report?
It is on 207.
Okay, let's take a peek at that.
Yep, 207, line 5.
Tell you what, just to make it clean, let's make the pen and ink correction, and then let's vote on it to make sure that, so the word really should say, or maybe this is editorial, I don't know. It's, Kathy's looking here. So it really, the main body of the report says that it should, for use in securing. Tell you what we'll do. Why don't we consider, if it's okay with you all, just so that it's not confusing to me, we just adopt the language that is on page 207 as a, we'll go and we'll call that one out separately, just to make sure that we know exactly what we're voting on. Is that?
That's fine.
Okay. All right, good. So let's, so that's recommendation number 23. Yeah. Okay, good. If you'll make sure that we pick that one up.
Okay.
Okay?
So I offer a motion to amend recommendation number 1 to the Secretary of Transportation. So it will now read, require the Federal Railroad Administration to issue regulations for inward-facing recorders that include visual and audio recordings as recommended by the National Transportation Safety Board in R-10-01 and R-10-02.
Thank you. There's a motion. Is there a second?
Second.
Okay, it's been moved by Member Hamady, seconded by the Vice Chairman. Discussion.
Just to explain, the current recommendation as drafted states require the FRA to comply with the FAST Act and issue regulations for inward-facing recorders that include audio recordings. The problem is the way the FAST Act is drafted, the FAST Act is very different than our recommendations on recorders. The FAST Act did not apply to all railroads. It only applied to intercity and commuter railroads. And it left the audio portion, the decision to include audio, up to the discretion of the Secretary, and then allowed the Secretary to exempt railroads from that requirement. So I wouldn't want us on record as stating that the FRA should comply with the FAST Act when our recommendations are broader. And all of that should be included. And then the end change where I added visual, I just wanted to be very clear what our recommendations are. It's not just audio, it's both visual and audio, since the rulemaking has not been completed.
Okay, thank you. Discussion, questions? Staff, what is your position?
Staff has a comment about the choice of the word visual in your proposed amendment. And would it be video in audio or visual in audio?
Yep, video is fine. Video is fine. However, we normally
Just
categorize
wanted
it.
to be real
Okay, so video.
clear.
To be consistent with the report, I believe it should be image recorder. Audio and image.
Okay.
Okay, thank you for those comments. And if we were to make the changes, Member Hamady, would you accept that as a friendly amendment to strike visual and replace with image? So it says include image and audio recordings?
Yep, so we would state, require the Federal Railroad Administration to issue regulations for inward-facing recorders that include image and audio recordings as recommended by, and then the rest the same, correct?
Staff
I'm good with it.
Yes, and staff would be, that's the language you'd prefer. Okay, so any further discussion? We have a motion to adopt, to amend recommendation number 1 as presented, as amended by Member Hamady and seconded. Is there further discussion? There's none. All in favor of that motion, please signal with a hand and say aye. Aye. Opposed? There are none. Recommendation number 1 has been amended unanimously. And Vice Chairman, I just want to make sure your proposal is going to deal with the potential reiterated recommendation.
And,
Is that
yeah,
correct?
and a classified.
Yeah. So I
yes.
just wanted to catch them in order, so that's good. Member Hamady, I recognize you for recommendation 5.
I offer a motion to amend recommendation number 5 to the Federal Railroad Administration so that it will now read that prohibit the operation of passenger trains on new, refurbished, or updated territory unless positive train control is implemented.
Okay, there's a motion. Is there a second?
Second.
The Vice Chairman has seconded it. Any discussion?
And just to explain, PTC is on our most wanted list of safety improvements. I know this was not intended, but the way it is drafted currently, it looks like we're allowing for an alternative technology. That was not the intent of how it was drafted, from what I understand. So I just wanted to clarify our desire that PTC be implemented and that these new operations or updated operations should not start unless PTC has been fully implemented on those routes.
Thank you for explaining that. Any discussion? Staff?
No discussion from staff, we support.
Thank you. It's been moved and seconded to amend recommendation 5 as motioned, as moved. All in favor, please signal with a hand and say aye.
Aye.
Opposed? There are none. Recommendation 5 has been amended unanimously. Now, recommendation 17, I believe.
I actually have 3 amendments to 17, 21, and 22, all of which are the same. So I was going to offer them together as a block.
Do any of my colleagues have any objections to doing them en bloc? Nope. We all see what the amendments are right here in front of us, so please proceed.
Thank you. For recommendation number 7, I offer a motion to amend safety recommendation number 17 as follows. And that's to Amtrak. Work with host railroads and states that own infrastructure over which you operate to conduct a comprehensive assessment of the territories to ensure that necessary wayside signs and plaques are identified, highly conspicuous, and strategically located to provide operating crews the information needed to safely operate their trains. The amendment to safety recommendation number 21 to Amtrak would read as follows. Work collaboratively with all host railroads and states that own infrastructure over which you operate in an effort to develop a comprehensive safety management system program that meets or exceeds the pending Federal Railroad Administration Regulation Title 49 Code of Federal Regulations Part 270 System Safety Program. And then my last amendment is to safety recommendation number 22 to Amtrak as follows. Conduct risk assessments on all new or upgraded services that occur on Amtrak-owned territory, host railroads, or in states that own infrastructure over which you operate.
Okay, it's been moved to amend recommendations 17, 21, and 22 as presented. Is there a second? Member Weiner has seconded that. Any discussion? Love to hear your reasons for that.
And again, this is just to clarify that Amtrak operates on territory not just that is their own or that is a host railroad, but also operates on routes in 4 different states, and those states own that infrastructure and are not considered to be host railroads.
Thank you very much. Discussion? Staff?
Staff supports.
Okay, thanks. It's been moved and seconded to amend recommendations 17, 21, and 22 as presented. All in favor, please signal with a hand and say aye.
Aye.
Opposed? There are none. Recommendations 17, 21, and 22 have been amended unanimously. Now, Member Hamady, if you'd be willing to make a motion regarding recommendation 23, and if so, I would say that we could refer to, what did we say page was? I've already lost it. What was the page?
231.
No, the,
207 line, it starts on line 3 of page 207.
and frankly, yeah, I think just to be clean, let's just look at, let's just read
Sure.
what that says on 207, lines 3 through 6, and we will amend basically the existing 23 with whatever you read. Does everybody understand what we're proposing to do there? Okay, if you'd kindly make that motion.
I offer a motion to amend recommendation number 23 as follows. Develop policies for the safe use of children's car seats to prevent uncontrolled or unexpected movements in passenger trains and provide customers with guidance for securing these child safety seats.
Okay, it's been moved. Is there a second?
Second.
The Vice Chairman seconds that. There's a lot of scurrying around here, so
Hold on. There was apparently some other
There should be car
Change.
safety seats in the first reference, child safety seat.
Okay.
Instead of children's car seats, child safety
what
seats.
we're really doing is we are now voting on a replacement recommendation. So whatever she read is the motion. It can say whatever. It doesn't have to be compared.
Can I withdraw my motion?
Please, you're withdrawing your motion.
Withdrawing the motion.
Okay, and you seconded it? Do you agree with that?
I do.
Okay.
Can I ask staff for clarification on how it
Yeah,
was
please.
supposed to read? I know there were different
Please.
iterations walking in here.
Yeah, that's true. Thank you.
And I think this was one of the pages that was replaced at some point.
Yeah, this was one that was replaced on Friday, this 17th. All right, let's
Staff
sort it
would
out. Go ahead.
Staff would propose the following language for consideration. Member Hamady, develop policies for the safe use of child safety seats to prevent uncontrolled or unexpected movements in passenger trains and provide customers with guidance for using these child safety seats.
Securing.
Securing.
Okay, so I'm going to try this. I offer a motion to amend safety recommendation number 23 as follows. Develop policies for the safe use of child safety seats to prevent uncontrolled or unexpected movements in passenger trains and provide customers with guidance for securing these child safety seats.
Just before we accept a second on that, is that what you were proposing? Because that's the way I wrote it down as well.
Yes, Chairman.
Okay, thank you. Okay, so it's been moved, and I tell you what I'd like for you to do. Let's read it one more time, and then we'll get a second on it. So your motion is as follows.
Develop policies for the safe use of child safety seats to prevent uncontrolled or unexpected movements in passenger trains and provide customers with guidance for securing these child safety seats.
Thank you. And that recommendation, of course, is to Amtrak, and it's been moved. Is there a second?
I'll re-second.
Okay, it's been seconded. Any discussion? And I appreciate your catching that it was different in the text than it was in the recommendations that were read. And that's what we're supposed to do. So thank you for that. Any discussion on that?
Staff supports.
Great. It's been moved and seconded to amend the existing recommendation 23 with the motion that Member Hamady has made, seconded by Vice Chairman Landsberg. All in favor, please signal with a hand and say aye. And I was not fast enough, but I think you raised your hand too, okay? Opposed, signal with a hand and say nay. Okay, the Amendment 23, recommendation 23 has been revised has been revised unanimously. Okay, so now we're to you, Vice Chairman Landsberg. I think you have a motion.
I do, Mr. Chairman. I have an amendment to offer, and I'd like to move to replace the language on page 232, which is reclassifying recommendation R16-32. So it would now read, safety recommendation R16-32 is classified open unacceptable action. And to reiterate the recommendation to FRA where appropriate in this report. That is my motion.
Okay, and I just want to clarify, we're not changing the language, you're not proposing to change the language of the recommendation. What you're proposing is to reclassify this recommendation. Is it currently, what's the current classification?
It's currently open acceptable.
Open acceptable, and you want to make it open unacceptable.
That is correct, and to reiterate it.
And to reiterate it. It's been moved to reclassify R16-32 as open unacceptable action and to reiterate it. Is there a second?
Second.
Is there any discussion?
May I explain?
You certainly may.
Okay. It seems that the FRA doesn't understand that GPS is readily available and there is no charge for using the GPS system, and that there are devices such as iPads and other screens that can be used in locomotive cabs that will not be distracting and would have prevented, I think, this accident had the crew's situational awareness been better. So that's my thought.
I couldn't agree more. Paid $7, $8 to get a taxi cab today, and there was an iPad or Surface or whatever it was that helped the taxi driver get from wherever we were to here. And I don't know why someone operating a train at 79 miles an hour would not have the advantage of a moving map display. We're not talking about just some Apple Maps. It would be customized for train operations, so I support it.
Thank you, sir. I think we'd like to help the FRA to understand this and move forward and at least come into the 21st century.
Discussion. Thank you. Staff?
Staff doesn't have any objection to the change, but we would just like to point out that the text in the report will need to be revised to justify keeping it open and the reason why we're keeping it open.
I very much appreciate that, and we have a couple of options. You could, why don't you, if it's acceptable with my colleagues on the board, once you redraft that text, circulate it for page changes, just so everybody's okay on that. Does that sound reasonable? It shouldn't be more than a few pages, a few lines, but if with the concurrence of my colleagues, we'll just circulate those pages for review. Any further? Thank you for pointing that out, Mr. Marcus. Any further comments?
No further comments from staff. In principle, we support.
Thank you very much. And so the motion is to reclassify. To reclassify R16-32, reclassify it to be open, unacceptable action or response.
Open, unacceptable response, not unacceptable action.
And to reiterate.
Okay. So it's open, unacceptable response.
Yes.
I probably misread that the first time. Reclassify open, unacceptable response and reclassify it. That's the motion that's been seconded. Ms. Silva,
And to reiterate, I believe, is the.
I'm sorry, I said that wrong. We will reclassify it and reiterate it. Yeah, thank you for catching that. Any further discussion? There's none. All in favor, please signal with the hand and say aye.
Aye.
Opposed, there are none. We will reclassify and reiterate that recommendation. Thank you very much. Are there any further amendments to the recommendations? So we've now made numerous revisions or amendments to the recommendations. Now we need individually. Now we need to go back and adopt them all. So do I have a motion to adopt the recommendations as revised?
I so move.
Okay, Member Weiner has moved. Member Hamady will second that.
Second.
Thank you. I'm sorry. It's 5:20. Any further discussion? Okay, Mr. Hiller, thank you. All in favor of adopting the findings, the recommendations as revised, please signal with a hand and say aye. Opposed? There are none. The recommendations have been adopted as revised unanimously. Any other discussion, anything else that my colleagues would like to discuss at this point before we move to the adoption of the final report?
I just wanted, I plan to vote yes on adoption of the final report. I just wanted to point out that there are some minor edits in the report that I think are being made, so my vote is, contingent on those tiny edits that will be made at some point, and these are just very small, not actually substantive.
Sure.
Editorial.
And yes, by definition, yes, editorial changes are not substantive by definition. And so my question to you is, do you want to see the report in its final form before? We already know we are going to circulate these page changes that we just talked about for the reiteration and the reclassification. Do you want to see the final report?
No, I'm okay.
Okay, thank you. Okay, I think I just heard a collective sigh. But absolutely, you're right. We want to make sure that those edits are made.
Yeah.
Any issues for discussion? Is there a motion to adopt the report as revised?
So moved.
The Vice Chairman has been seconded by Member Weiner. Further discussion? The motion has been moved and seconded. All of those in favor of adopting the report as revised, please signal with a hand and say aye. Opposed, there are none. The report has been adopted unanimously. Do any members wish the right to file a concurring or dissenting statement?
I would.
I think I would too.
Okay, that's two. Members Hamady and the Vice Chairman would like to file a concurring or dissenting statement. Any further discussion? Well, in closing, staff, thank you for your hard work. Really appreciate that. I want to thank my colleagues, Member Weiner, Vice Chairman Landsberg, Member Hamady, for all of your comments. We all had a lot of comments after we individually met with staff. We very much appreciate your evaluating those comments and incorporating where you feel appropriate. It's been a good board meeting, good debate, good discussion. I want to thank Mike Hiller for taking over as the investigator in charge. I'd like to thank Ted Turpin for serving as the investigator in charge as well for most of the investigation. Thank you all. I always say nothing gets done around here without a team effort. A sincere thank you on behalf of my colleagues to not only the investigative staff and management, but to the program and the support staff as well. Today's new and reiterated and reclassified recommendations, if acted upon, will make railroad transportation safer for passengers and train crews, but they will require action by several parties, including the Federal Railroad Administration. The repeated postponement of Title 49 Code of Federal Regulations, Parts 270, System Safety Program, has delayed needed safety improvements on passenger rail. How many stays of that have we had now? 6? It's time. It's time to move forward on it. We want the FRA to move. They're saying it will be done by September, in September. It's time, it's past time to get it done. There's no other way to put it. It's time, it's past time for the FRA to act. As we've seen today, lives depend on the issuance of that rule. We stand adjourned.